With his strong academic background and research orientation, Patankar sir brings valuable insights into AI and DS applications, making his session highly relevant for
Tiffin,
faculty members and
tiffin निकाल
researchers.
दो.
Now I will hand over the session to you, sir.
रुकना.
Thank you.
Okay, madam. Thank you. Okay, good evening to all the participants and also the organizers of ATAL-FDP on topic recent trends in artificial intelligence and data science. I heartily welcome all the participants for today's session. Actually, I'm going to deliver today's session based on multiple topics in data mining. Okay, so few topics mostly many participants might be familiar with. So on case study basis, we are going to discuss that. So the topic which I am presenting is having data pre-processing, which is one of the part of data mining, then feature engineering, then dimensionality reduction, and machine learning operations. That is introduction to machine learning operations. So this is a combination of variety of things which are used in machine learning. So I again welcome all the participants for today's my session on my topic. As I told you, data pre-processing, feature engineering, dimensionality reduction, and introduction to ML machine learning operations. All these things we are going to discuss today. Okay, so as madam has introduced, I'm going to deliver this session based on case studies. So to start with, this is a outline presentation overview. Is the screen completely visible and I am audible clearly to everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay, okay, thank you very much. So these are the topics that we are going to discuss. Data, what is data pre-processing? What is feature engineering? What is the dimensionality reduction? Now, data pre-processing is known to everyone. Why we need to process the data? Basically, data is a core part of any organization or anything you want to do with that. That is the processing. So today, processing of big data and other thing is very challenging. So what is the need of basic data processing? I will start with basic things. So data in the real world is dirty. Means what? It is incomplete, noisy, inconsistent. Because someone, company manager told you to gather data. Then if you are doing research, your research supervisor told you to gather data from these sources. You download it. But what you find specifically about research scholars, they find that data is incomplete. Some data is missing. Some data which is fields are there, but you are not able to use that. And some data, even though it is halfly generated. So what to do with that data? So basic part we are looking here is pre-processing of data. Unless and until you pre-process that data directly, if you take that raw data, then you cannot get your achieved whatever the targets or whatever your research objectives, you are not able to get. So what is meaning of incomplete data? Incomplete data means what? It is having lacking of attribute values, some attributes like some attribute values, name, pin code, something is missing, then lacking certain attributes of interest. Basically, you are looking for salary component of any organization, but the data doesn't have that component. Then what to do? Or it is having aggregate data. So you want separate month-wise and year-wise data is given. So what to do? So we call in data mining terminology as incomplete data. Then noisy data. Noisy data consisting of errors or outliers. Means what? The things that you want to consider for your research, but actually that things are not there. Means some error values, some deviation from actual values are there. So you call it as a noisy data, which is you require to remove that noise and make that data again for use in pre-processing. Then some data is inconsistent. Means what? It is consisting some discrepancies in code or name. So that discrepancies we need to remove to make it consistent and become in that data will make in use. So that is what these operations we need to perform on the data. So major tasks, what we are going to perform on data, basic tasks are there, because unless and until we accomplish this task, we cannot process that data. So data cleaning, what is that? Data cleaning means filling the missing values. Some data is missing, and like suppose age is missing and other attributes are matching. So you have to fill based on other parameters, fill that missing value, smooth the noisy data. So some data that you have to apply binning method and mean mode method, then finding that missing value, identify or remove outliers, some data which is not at all required, which is not part of your whatever the purpose that your data is gathering. So you have to remove that and resolve the inconsistencies. So all these things come under cleaning. Cleaning is the first task you need to perform on the raw data. Then integration of multiple data sets, cubes, or files. So we don't have only data of single pattern. Whatever result or outcome of research we want to achieve, or whatever we want to process, that is collected from multiple data sets. So data integration is having integration of multiple data sets filed together, grouped together, which is used combinedly for processing. So as well as cleaning, integration is also very important. Then transformation, normalization, aggregation. Like you want to transform one form of data into other form. Like if you have given monthly salary, then you have to convert into average salary of the year. Then average salary is given of the year, you need monthly salary, you need to normalize or aggregate it as per your requirement. So that kind of transformation, converting one form of data into other, relevant. There is a very important term, relevant. If you do the transformation, but relevance of the data is changing, then that data is also of no use for your research or any application that you are using. So this task you need to perform very critically. Then reduction, reduce representation in volume, but produces the same or similar analytical results. So sometimes you need to do the aggregation, and sometimes you need to compress that data in some format, so that it comes under reduction. And discretization, that is part of the data reduction, but with particular importance for numerical data. So we need to calculate discrete value of the data and use it. So all these are basic operations we need to perform on data. Unless and until we do that operations, we are not able to use that data as per our requirement. So this is a basic thing that we required in data pre-processing. So this is well known to everyone. What is cleaning? What is integration? Multiple data sets grouped together. Transformation, one form of data is transformed into another form. Reduction, like multiple dimensions are given, only required dimensions we need to transform. So this is the one type of transformation from many dimension to required dimension. So such activities we call as pre-processing activities. Okay, so this is pre-processing requirement. Now I will consider one case study, how pre-processing works and why it is important. So we consider one case study of data pre-processing, and it's important in online railway booking system. Suppose like IRCTC, which allow passengers, what are the options that online booking system will provide to you? They will provide you online booking, book the train, check the availability of tickets, book and cancel the tickets. You can do the online payments, and system generates large volume of data from millions of users every day, because that is widely used by everyone. So before this data can be used for analytics, then demand prediction, fraud detection, and service improvement, it must undergo pre-processing, because so many things. Someone has entered wrong age, someone has entered wrong birth, all this data wrongly they filled, and system may take means if you are not checking the parameters that entered by the user are not correct. So what to do with that? So we need to have the pre-processing. So the railway authority face issues such as inaccurate passenger statistics. All the statistics provided by passenger are not correct. Then poor demand forecasting during peak seasons. So peak seasons, you cannot have all the whatever the demand taken asked by a user, you cannot fulfill. Then like in the summer and other seasons, duplicate and incomplete booking records. Sometimes incomplete booking, some value missing, some records, same duplicate entries they are doing, delay in analytical reporting. So those problems occur due to raw, inconsistent and noisy data. Because too many entries, some agents are just making the entries randomly. So that raw, inconsistent and noisy data is generated. Now for that data pre-processing, before we process for displaying final chart for booking, we require to pre-process that data. How to do that? Missing values like passenger age, ID, number, if this is missing. So you have to enter this missing value. Then duplicate records, like multiple bookings for same passenger. Same passenger is doing multiple bookings. So duplicate records are generated in your database. Inconsistent format. Someone is for entering date and time in different format. Someone is entering station code. Someone is not entering. Noisy data, that is invalid ages. Someone is writing 105, 120, some random values. Incorrect train numbers, like 1020 up. So it is he's writing 1010, like that. Some noisy data they enter. Then categorical, class, payment mode. Then outliers, bulk booking during the festival. So some data which is not expected, that also get entered by the users. So this is the issue which is identified while doing the bulk booking, or generally when we do the identified issues when the booking is done. So how to make our system more stronger so that all these issues are to be handled. Now, what are the things we require to do? We require all these operations that we discuss for this online railway booking system. First of all, we require to do the cleaning operation. Now, what we are doing in cleaning to improve the accuracy, like remove duplicate booking record, first of all, find and remove. Then fill missing passenger age using median age, like calculate the average or median, and suppose one passenger age is missing. So we calculate the median of all age and insert the age value. Then remove the invalid entry. We should check at the time of entry that age should not be 0 and should not be greater than 100. So all these filters we have to apply while entering the data. Then correct station codes and train numbers that we have to provide. So age equal to null, replace with median age. So whatever the null value, it should have some value. Otherwise, we are not able to process that data. So all these operations we are doing under data cleaning, removing duplicates, median value of age, checking the validation of age, correct age is entered. Then second operation, integration. Combine data from multiple systems, like merge booking data with payment data. Link cancellation log with booking records. Whatever the log of cancellation done, we link with booking record, whether same booking is cancelled or different booking is cancelled. So that integration is important. Resolve attribute conflicts like PNR, booking ID, whatever the PNR value we are entering, what is the booking ID, we need to check that. And unverified railway transaction data sets, that data set we need to have to generate with multiple integration of different data sets, like different log values we need to merge and use that data. Then reduction. All these basics, all these are the basic pre-processing operations that we have discussed. What is the objective of data reduction? Basically, we don't have to have large size data. We need to reduce the data size and complexity. We remove the unnecessary attributes like remarks. Sometimes you write in the remarks, comments. We don't require that for processing. So why to consider them? We reduce them by data reduction. Then aggregate daily booking into monthly statistics. Suppose yearly booking we want to consider. So we go for aggregation. Then apply feature selection. Only selected features we apply and generate the data set. So we are not looking for whole complete data set, but compressed or reduced data set that we are looking for. Then data transformation. What is the objective of transformation? Converting one form of data into other form. So in this specific case study, we convert data into suitable format, like normalize the fair amount, encode categorical values like class or payment mode. We have to have online payment or other thing. We categorize them and convert date and time into feature like month, day, hours. And we change. When we are sleeper class, we write 1, 3A2 and 2A3. Like that, we use the transforming this data. So what is the advantage of transformation? We should have all the unique values of all the classes and labels that we are entering. So this is data discretization, fifth operation of data pre-processing, that is convert continuous data to categories. Now, what is the purpose of categories? Because we want to say that age group belong from what? Suppose it is from 1 to 16, we call that child. 16 to say onwards, 16 to 60 adults, and 60 onwards senior citizen. So this is the categorization. So age is discretized into 3 different categories. Then travel is also discretized into 3 different categories, and fare is also discretized into 3 different categories. It is up to us when we are designing the system. So continuous data value can be categorized so that you don't have to display all the data value. After doing all this pre-processing, how the data will look like? See, PNR value, age group, whether it is from adult or senior, sorry, whether from which, going where, 3A class, then fare category, we say that low, medium or high. Instead of displaying the fare amount, we say that we categorize them between some parameters. So we say that it is medium and booking type, whether it is reserve or confirm. So this is the final result we are displaying as a chart after data pre-processing. Now, what are the benefits we are getting? We are having accurate passenger analytics, better demand forecasting, improved seat allocation, then faster reporting and decision making. We have to generate the charts very fastly and accurately, and reduce fraud and duplicate bookings. So fraud and duplicate bookings are avoided. So these are all benefits we are getting by data pre-processing. Okay. So this is all about the case study of data pre-processing. So I hope all of you understood, means everyone knows, but as a case study, I have tried to signify what is the importance of data pre-processing. So sample case study we have discussed. Now, next part, that is feature engineering. That is the second part in machine learning. What is feature engineering? So you are able to see the diagram where actually this feature extraction we are doing, and that comes under feature engineering principle. So here data we gathered from different sources, then we collect it as a raw data. Then we have to have clean and data cleaning and transformation. So here we have to apply this feature engineering. So exact features that we are looking for are extracted from the raw data. Then we model the data, and after that we get the insights of the data. Now, feature engineering in data science refer to manipulation, addition, deletion, combination, mutation of your data set to improve the machine learning model training. Now you know, everyone, what is the training? We train the model, then we call that as a training data set, and then actual data set we get, and then we test it on the, we call it as a test data, and then we verify whether as per training model, whether test data is getting worked or not. So when we are doing feature engineering means what? Whatever raw data we are doing clean and transform. So instead of cleaning and transform, we do some additional like manipulation, addition, deletion, combination, mutation to improve the machine learning model training. So leading to better performance and greater accuracy. So after applying these all operation, we get better features, greater accuracy, and effective featuring engineering is based on sound knowledge of business problem and available data sources. So whatever the available data sources, from there we gather and apply the feature engineering principle to model data and we get the insight of it. So this is the importance of feature engineering. So here we need to apply not only basic data pre-processing, but also improvement model. So improvement so that our training data set, which is used for developing the model, is getting accurate. And then accuracy is increased further in our actual data set when we are using. So what is the importance of feature engineering in machine learning? Feature engineering is very, very important in all types of ML application. But why we require that? So that is also important. Okay. So what is the importance of feature engineering? Feature engineering can significantly influence the model performance by referring features like accuracy improvement. We are focusing on in feature engineering, reduce overfitting, boost interoperability, enhance the efficiency. So all these are the significant things that we are looking why we are doing feature engineering. So it is similar process as data pre-processing, but improve accuracy, choosing the right feature, help model learn better, then leading to more accurate prediction. Like suppose we are choosing some different, gathering some data of students from different sources. We choose important features like date, birth date of the student, then when that student admitted for the course, then when that student is expected to complete the course. So all these are the key features that we choose, and that data only we consider for processing. Then it improves the accuracy. Instead of considering all the data, choosing the right features help the model to learn better. What is our main aim that we have to consider, and accordingly we need to choose the features. So that feature selection we are doing in feature engineering. Then reduce overfitting, using fewer more important feature help the model avoid memorizing the data and perform better or new data. Means overfitting, unnecessary, if some certain field or features are not required, still we consider that when we collect the raw data, but we are not doing feature engineering, then what happens? It is an additional burden for processing that data. So reduce overfitting using fewer or more important features only, as less as feature we have to consider for training our model. That is what we can do in the reduce overfitting in feature engineering. Then boost interpretability. Well chosen features like make it easier to understand how the model makes its prediction. So prediction based model. So its interpretability must be improved by choosing the important features to understand the model. So which features that we have to identify. So all these operations we are doing on the raw data set. Then enhance efficiency, focusing on key features speed up the model's training and prediction process and saving the time and resources. So if you save the time of processing and saving the resources, ultimately your application efficiency gets enhanced. So these are the very, very important features that we have to look for feature engineering. And feature engineering apply when we are gathering the data. After that, pre-processing and feature engineering we apply for making the training data set, training our model. So process involved in feature engineering. So all these 5 features we have to create, or we have to take while we do the feature engineering. So first task is create the feature. Feature creation involves gathering new features from domain knowledge or by observing patterns in the data. So here feature creation is very important for generating the new feature from domain knowledge. You have the domain knowledge. You create the new feature by observing the pattern. So this feature is useful. your created new feature is useful for training dataset for processing the data. So that is very important of creating the feature. From existing domain knowledge, you create new features, which is useful for your data processing and training and testing the data. Then feature transformation. Transformation adjusts feature to improve the model learning. So you have to learn the model, then you need to do some transformation so that learning becomes easy. So adjust the features as per your requirement. Means some features are having different attributes. So you have to adjust them as per your requirement of your application. So that transformation is there in the feature engineering. As per your requirement, you have to transform your feature and you can create new feature. So these are these two tasks. Feature extraction. Extracting meaningful features can reduce the dimensionality and improve the model accuracy. So you want accuracy also, you want to reduce the dimensions also, because you don't want large data to get processed. So only required features you extract and use them. So dimensionality get reduced and accuracy also improve. So that is also important. Extracting only required features. Then feature selection. Feature selection involves choosing a subset of relevant feature to use. You have lots of features. You have to select subset of the features which is only required for that application or for that purpose, whatever the purpose you decided. And feature scaling. That is, scaling ensure that all features we can have contribute equally to the model. If some features selected but not contributing, not is in use, what to do with that? So scaling of feature is very important to ensure that all the selected features are contributing equally for developing our model. Okay, so all these activities comes under feature engineering. So feature engineering is important process. Now, what is the steps that you have to perform in feature engineering? These are all step-by-step process, and it is very in detail study we required. But I have tried, because of 1.5 hour time constraint and many topics, I have considered very important aspects which you need to understand about feature engineering. So what are the feature engineering that very depend on specific problem. So what are these? First is data cleaning. You require to identify and correct the errors or inconsistencies. So you do the cleaning process. Then transformation as transform raw data into format suitable for modeling, scaling, and normalization. Whatever need to transform from one form to other form. Feature extraction. Create new feature by combining or we can say deriving information from existing one to provide more meaningful input to the model. So extract only require the features, then select features. Choose the most relevant features for the model using techniques like correlation analysis, mutual information, and stepwise regression. So regression, correlation you can use for selecting features. So selection feature is very important, because if you choose proper features, then your further data analysis become more easier. And feature iteration. Consistently refine feature based on the model performance by adding, removing, modifying features for improvement. If you don't do that, if you apply static features, you are not modifying in iteration, your results get affected. So you get this feature iteration, continuously refine the features. Like 2 features you have not considered, but they are essential. Remove old feature, add new feature, again give the data set, again check what are the results. So that is in iteration you need to apply. So after applying all these steps, you will get better performance. Means rather than only pre-processing, if you do pre-processing with feature engineering, you will get more trained model, more accurate results, and whatever the essential features. So performance, accuracy, everything gets improved for your ML model. So this is very important step, feature engineering in ML. So these 2 things that we have covered. Now we are moving towards third step, that is dimensionality reduction in machine learning. So this is also important aspect in machine learning. What is meaning of dimensionality reduction. So as you are able to see 3 diagrams on your screen. So what are these 3 diagrams? First, it is having 3 dimensions. Okay, I'll show you that. So this is for 1, 2, and 3 dimensions. Second diagram, you are able to see only 2 dimensions, and third diagram only 1 single dimension. So what is happening? So same data set which is represented in 3 different dimensions, same data set we have tried to map in the 2 dimension X and Y, and same on single dimension. So here we call this model dimensionality reduction. Now, what is the significance of dimensionality reduction in machine learning? Same data set. So dimensionality reduction is a process of reducing the number of input variables. We call them as a features. So this is one feature, this is another feature, this is another feature in data set, while preserving as much important information as possible. So whatever is significant, like some dimensions you are considering, so we represent them in 2, and whatever important significant we represent in 1. So what is the advantage we get by dimensionality reduction? Preserving as much important information as possible we can do. We cannot preserve all the dimensions which we are using in 3D into 2D and 2D into 1D. But whatever is essential for our ML model, we consider. So what is the advantage and disadvantage of dimensionality reduction? Basically, simplify the pattern, representation, and classifier. This is first important. Unless and until you simplify your pattern, if you give 4D, 5D model, then different patterns, then model takes time for analyzing, processing, and utilizing, and what we can say further generating the different result. But if we simplify the pattern in single dimension 1D array, then it is representation and classification becomes very easy. Faster classifier with less memory consumption. We apply classifier very fast, and memory consumption is also less because we are reducing multiple dimension to single dimension. All data sets are mapped, all 4 variety of data set. So that is advantage, faster and classification. Then elevate course of dimensionality with limited data sample. So we have limited data sample, which is essential only for data processing that we consider. But what is the loss? Advantage are there. We get less time and processing and fast classification. Everything is there. But limitations are, we may have some important information which we map in this 2 or 3 dimension, which may get lost, and which is very essential for your creating your model. So that is loss. Then increase error in the resulting recognition system. So error increases and some information may get lost. So these are some advantages and drawbacks of dimensionality reduction. So this is one of the important concept in machine learning. So at what extent you reduce, it is up to you. You have to check while doing that whether what kind of data loss, whether relevant data loss is there, then we have to limit it to 2D. Then it is up to us. Okay. So dimensionality reduction techniques. How to do that reduction? So 2 methods are there in dimensionality reduction. First one is selecting the features, and second one is extracting the feature. Now, features, I told you what are the significant important features that you need to select. You cannot consider all the parameters. So dimensionality reduction, you have to select the features and extract the features. These only 2 steps are there. Now, what are the steps in feature selection? You have to apply filter method, wrapper method, or embedded method. Either you wrap the data, you embed the data, or you filter the data. These are the three methods you can do in dimensionality reduction. Then feature extraction. So this is very popular, principal component analysis, where we need to consider sample components and do the analysis. Then missing value ratio. Then backward feature selection, forward feature selection, factor analysis, independent component analysis. All these are extraction of the features. Which features are essential for data handling? We are doing it in feature extraction. Now, these two steps we'll discuss. What is feature selection first, and then later on, what is feature extraction. So these two are the important steps in reduction of dimensionality. So dimensionality reduction means converting multiple dimensions to trying to single dimension. So what is first? Feature selection. So feature selection chooses the most relevant features from the data set without altering them. Only select, don't alter. That's why this step is called as feature selection. It helps remove redundant or irrelevant feature, improving the model efficiency. So selecting features will, it is now given to the developer that you are having authority to choose the features. So you choose only relevant. So redundant features are not chosen. So remove the redundancy. Then irrelevant features are also not chosen. So it is up to the designer. So who is designing. So this advantage we are getting in feature selection. Now some common methods which filter method. In filter method, rank the feature based on their relevance to the target variable. We rank the feature, like selected one feature, like we are developing results of all the universities. Now, which is important feature? Suppose subject-wise mark. Now, filter method rank the feature based on their relevance. So, mark is the topmost rank for my feature. So, I will consider as rank 1. Then location or address of the student is not relevant feature for my whatever the task I am doing. So I mark that as a lowest rank. So which rank, higher or lower, that I can mark using feature selection. I can rank my feature. Without this rank 1, 2, 3 feature, I am not able to do my analysis properly. Then rank number 8, 9, 10, you may consider, you may not consider. It is up to you. So that is filter selection method. Then second, wrapper method. It is use the model performance as the criteria for selecting features. So you wrap multiple features together to combine it as a single feature. Because you want marks also, you want previous grades also, you want something. So you group them together and mark them as one feature. Like we do the transformation, like that you transform the multiple values and create new feature. So that is called as a wrapping method in feature selection. Then embedded method, combine feature selection with model training process. So embed means one feature you integrate into another feature, combining the selection. So these are the 3 methods: filtering, wrapping, and embedding, which we can do in the feature selection. Then extraction. Feature extraction involves creating new feature by combining or transforming the original feature. Now in extraction, we have to create new feature by combine. We have to either combine or transform the new feature. So these new feature retain most of the data sets important information in fewer dimensions. Now only we extract the required part by combining or transforming. So principal component analysis, this is very, very important method in feature extraction. Those who are working in machine learning, they know about the PCA. So PCA converts correlated variable into uncorrelated principal component, hence reducing the dimensionality. Now your original data set, you have different variables which are you need to correlate with the different components. So you can use this component in the reducing the dimensionality. So you are 6 to 7 dimensions or 4 dimensions, after doing PCA, you need to map it with the single or other many or single or 2 dimensions. So that way you do the PCA analysis. So while maintaining as such variance as possible and enabling more efficient analysis. So this process will give you efficient analysis by we can say converting or correlating variables into different components. So whatever variables you have in your data set, it correlate with the different component and reducing the dimensionality. Basically, PCA is the activity in feature extraction mostly done or applied for reduction of the dimensionality. PCA. Okay, so more details you can have. Basic purpose is reducing the dimensionality by means correlating your variables with the different components which are of your interest. So after you made the correlation, automatically you reduce the dimensionality because multiple variables you map with the one dimension. That is how PCA works. Then missing value ratio. So variables with missing data beyond a set of threshold are removed. Like certain threshold, like age group in our application of reservation. Whatever the result value after 100 age threshold are removed. And certain improving data set reliability. So missing value ratio we have to improve in feature extraction. Backward feature elimination. Start with all features and remove least significant one in each
Hello.
iteration. So this
Hello.
process continue. Yes.
Hello. Sir, so sorry to disturb you in the middle. Actually, my net is not working and some feedback link has been shared in the chat. I'm not getting it. I'm trying continuously to get that link, but I'm not getting because some problems. So can you post the link in the group? Sorry to disturb this.
I have to post the link.
Yeah, in the group, I request the host to please post the group in link in the group because
Madam, already there is YouTube live streaming. You can see the video over there on live streaming also.
no,
But I
sir,
don't have link, madam.
feedback link. I'm requesting to the host because there is some problem in
no
my
feedback link shared until now. There is no feedback link shared.
We will provide you YouTube link.
It is a YouTube link.
And you can see it afterwards also and live streaming also. Feedback link. Feedback link. It will be shared
We will
at the
share
end
the
of the
feedback
session.
link in some time, ma'am.
Okay, shall we continue?
Yes, sir, you can continue.
Okay, fine. So what is missing value ratio? Principal component analysis I have covered. Then missing value ratio also covered. Backward feature elimination starts with all features and remove the least significant one in the iteration. So whatever is the least significant and more significant, you categorize them and remove the features which are not at all relevant with your process. So process continue until only the most impactful feature remain optimizing model performance. Then forward feature, similar to backward, it begins with one feature, add other incrementally. Now, you initially consider two features which are essential for my analysis or for my data processing. Later on, you think that I require another two. So you can add these two. So you can have forward feature selection. So feature add another incrementally and keep this improving model performance. So as per your requirement, not initially only you consider 6 feature and work only with 6, and sometimes you feel that only 4 among them are relevant. So you are not able to remove them. So not like that. So forward feature selection allow you to add, and backward feature elimination allow you to remove any feature at any time. That is very important. And this facility allows you to reduce the dimension of your original data set. That is also important. Then random forest. Random forest uses decision tree to evaluate feature importance automatically selecting the most relevant feature. So this is the automated method which only relevant feature of your targeted applications are selected without the need for manual coding, enhance the model accuracy. So random forest is one of the technique of feature extraction. Only apply the random forest algorithm, it will give you the relevant feature for your application. So automated process. Then factor analysis, groups variable by correlation. So this is here the correlation and keep the most relevant one for feature analysis. So factor analysis, apply the correlation. It will try to map one relation data set with other. So this mapping will help to analyze where this correlation value can be found. This is the factor analysis. And lastly, in feature extraction, independent component analysis. It is also called as ICA. So it identifies statistically independent component ideal for application like we can say blind source separation, where traditional correlation-based method fall. So here in independent component, now here we are to work on independent component, not for all component or features. So identifies statistically independent component ideal for application. Now the component which are not ideal are not chosen. So we only identify the components which are identical or we can useful for our application. So these two process, selection of feature and extraction of feature, will make your data model here into small set. Okay, and that will improve your classification, then faster classification, and limited data sample you need to handle. So large volume of data can be compressed or reduced into small set, and you get result effectively. So that is dimensionality reduction. It is very, very essential. So after your feature engineering, this dimensionality reduction is very, very important. We have to apply by feature selection and feature extraction. Okay, so some real world use cases here. I'm not going to cover one case study, but some sample cases I will tell how we can use the dimensionality reduction. Dimensionality, and all papers are there. If you find so many papers are written on this dimensionality reduction in Scopus and other. So this is one of the key area of research, how we apply feature selection and extraction method. So dimensionality reduction plays very important role in many real world applications such as text categorization, image retrieval, Gini expression analysis. Now what is text categorization? With vast amount of online data, dimensionality reduction helps classify text document into predefined categories by reducing the feature space like word or phrase features while maintaining the accuracy. So reducing the feature space like word or phrase can be reduced into meaningful word. So you categorize the text and important features, analyzing that text, and it will be transformed into another text. So text categorization, that reducing in the dimensionality. So much text categorized into small text. Then image retrieval. As image data grows, indexing based on visual content like color, texture, shape, rather than just text description has become essential. So this allows better retrieval of images from large data set. So this dimensionality reduction is also applicable in image retrieval. So images data grows, indexing based on visual content. So color, texture, shape that we consider, and exact retrieval of image from data set that we can identify in image retrieval. Then Gini expression analysis. So dimensionality reduction accelerates Gini expression analysis, helps to classify samples like leukemia by identifying key features, improve both speed and accuracy. So what is the leukemia, whether other features are matching or not that. So we create the model by Gini expression analysis. So here we apply the dimensionality reduction. And lastly, this is the most popular, intrusion detection in cyber security. Dimensionality reduction using intrusion detection. So in cybersecurity, dimensionality reduction help to analyze user activity patterns to reduce the suspicious behavior. So detect, sorry, not reduce, to detect the suspicious behavior and intrusions by identifying optimal features of network monitoring. So you identify optimal features, then you identify the suspicious behavior on the network. So intrusion detection using dimensionality reduction. So many papers are there. I will show you if time permits. Intrusion detection paper are there. Then Gini expression analysis, lots of work is going on. So this kind of work in ML you can do using dimensionality reduction, because text categorization, text sampling, it requires time for explain. So you just search on papers relevant to this if you want to more work on dimensionality reduction. Okay, so these are the real world case studies where dimensionality reduction can be applied. Now, what are the advantages of reduction in dimensionality? Faster computation, better visualization, and prevent outfitting. So faster computation with fewer feature, machine learning algorithm can process data more quickly. So only few features allow you to process data. That is the fast computation. Then better visualization. As we saw in earlier figure, reducing the dimension makes it easier to visualize data and reveal hidden patterns. So better visualization you get by reducing the dimensionality, and prevent outfitting. With few features, models are less likely to memorize. You cannot remember all the features and models which you are using in machine learning. So training data set and overfit. So this helps the model, we can say, generalize better to new unseen data, improve its ability to make accurate prediction. So data improvement and prediction is becoming easy using dimensionality reduction. So these are the advantages. And losses, data loss, reduce accuracy. Some important information may get lost during the dimensionality reduction. And ultimately, this loss of data causes the model performance. Okay, model performance gets degraded because of loss of data. So that is one of the drawback in dimensionality reduction. Then choosing the right component. If you are not choosing right component, so deciding how many dimensions to keep is difficult, as keeping too few and many lose values means information, while keeping too many can lead to overfitting. So you have that problem. If you choose less value, you are under not getting correct result. And if you are getting large value, you are having problem of overfitting. So choosing the right component is the challenge. If you are not doing that, you will not get the correct performance. So these are the two limitations of dimensionality reduction. So that is the end of dimensionality reduction. I have considered things that which are relevant for this model of dimensionality reduction, and these are some of the case studies that more papers you can learn on that. Now, last part for today's discussion, that is machine learning operations. Now, it is also known as MLOps, and we compare this MLOps with DevOps. So many of the audience or participants might be knowing what is DevOps. Okay, so MLOps is the concept, standard concept, which is built as per the DevOps. Okay, so we compare both of them. What is the DevOps and MLOps? So basically, it is a new terminology, MLOps. So it is called as machine learning operations. Now, what kind of operations covered under MLOps? It is a set of methods that help data science and engineering terms, which manage the entire machine learning process from collecting data, training model, to develop and monitoring them in real world system. Now, what you are getting by these words? So it is a set of methods that help data science and engineering terms to manage the entire machine learning process from collecting data and training model. So all these things are doing irrelevant with each other. That is called as machine learning operations. So which operations you need to perform? Manage the entire machine learning process from collecting data, training model, and deploying and monitoring. So train data, collect data collection, data training model, develop the model, and monitor the performance in any real-time system. All these tasks are performed by MLOps, machine learning operation. Now you are able to see the diagram. You can think of MLOps as a bridge between machine learning and daily operation. So it forms the bridge from your day-to-day operation and daily operation. It brings the structure, order, and automation to machine learning process. So we are going for automation in machine learning through the machine learning ops. Now in day-to-day life, we can plan, we can create data, we can build the model, and we can test the data. Now after this is our normal operation: planning, data collection, building model, and testing, and apply that model and test it. But we can apply the ML machine learning of by, we can say, packaging, deploying, then we can have predict serving and performance monitoring. So after you say that performance is degraded, again plan, build model, again test, again do the packaging, deploy, check performance, and again set the model. So this is a continuous process. Some processes for ML like data collection, training, deploying, monitoring, all these are all one followed by other. So all these tasks which are performed one after other are grouped together, and it will create one loop that is called as machine learning operation. All the operations which are essential for performing this are called as machine learning operation. So it bridges between machine learning and daily operation. So ML operation are planning, data model creation, and testing, and ML ops comes under packaging, deploying, then predict serving, and performance monitoring. Again you plan best if it is not there. So that comes under ML ops. So this is the central place. You are able to see ML ops. How they are at the central place? So it is nothing but machine learning and operation. So what is machine learning? Here, feature engineering, model development, all these machine learning. Then this is a DevOps. That is automated release management, automated testing, performance monitoring, model versioning model, all these DevOps you say. And data engineering, data collection, data analysis. So it is a combination of all these ML, data, and DevOps. So all these features, data pre-processing, model versioning, data versioning, all comes under machine learning operation. So it is an integration of all these three: DevOps, data engineering apps, and ML apps. So we are at the center with all these activity. We call them as ML ops. So what is ML ops? It is a machine learning plus its operation. What is operation? Data engineering and DevOps operation. So automation, mostly it is related with automation. Automation of ML processes. That is comes under ML ops. Now how to do that? That is again the challenge. Means how we apply automated processes for existing data model so that it will perform better. How we compare it with DevOps. What are the things we are doing, developing applications, and how we are doing this automation so that our ML approach become more impactful. Okay. So impactful in terms of feature prediction, impactful in terms of data analysis, visualization, and correlation. So how to do that? So a set of, we can say, practices focused on rapidly and reliably developing, deploying, and maintaining ML model in production. So it is a rapid processing, rapidly, reliably developing and deploying, maintaining ML model. So we need to rapidly develop, deploy, and maintain the ML model. How we can do that? By ML ops. Rapid means without any time, we create, develop model, deploy model, and maintain its flow. So we can say foster, gather communication and collaboration between data engineers, data scientists, and operation professionals. So it is activity handled by data engineers, data scientists, and operational professionals. Those who are working for operations. Okay, so they are managing that. Now, why this is important? ML ops, machine learning operation. Actually, it is a very deep study, but as far as one case study I have considered here also, how to apply ML ops and what are the features we are covering in ML ops. So much research is also going on in this area. Now, why is ML ops more important? So imagine you build a model to predict house price and it works well on your computer. Now you have developed one model, ML model, which predicts the house. So you train your model by giving prices of different house and then give some testing data set and it will predict. But it works on your system. But when you try to use it on website, problem arise like choosing the right model version, handling updated data. So much data is now gathered from all different places. So parameter you set for your computer will not work for that. So you need to revise again your data model for house prediction. So retaining regularly by checking performance. So this where the MLOps helps. Now, if you want to transform same your app into website, what are the challenges? Choosing the right model, version, update handling, and retention of regular data and performance checking. All these are the major issues when we deploy the same model which we have worked onto website. So all your work is well organized and version. So MLOps help you to organize your work, and also you can easily repeat model training and testing. So model can be updated and used in real world application without extra effort. So you don't have to put extra effort, you just apply MLOps. So in short, MLOps bring consistency, reliability, efficiency to machine learning framework. So it increases the consistency, reliable, you can rely on MLOps that it will work for any kind of whatever the platform you deploy, and it is efficient also. Okay, so that is how the MLOps added additional boosting in your regular ML operation. So making it accommodate to any sufficient. So how we compare MLOps with DevOps? So MLOps and DevOps are both, we can say, practices that aim to improve the processes where you develop, deploy, and monitor software application. In DevOps, what will happen? We develop, we deploy, and monitor. So same thing we apply in MLOps also, because it is an integration. You see the symbol of MLOps. It is a continuous integration process. Okay. So DevOps aims to bridge the gap between development and operation team. DevOps help ensure that code changes are automatically tested, integrated, and deployed to production efficiently and reliably. It improves, or we can say it promotes a culture of collaboration to achieve faster release cycles, improved application quality, and more efficient use of resources. It allows you to use resources more effectively and improve application quality also. So MLOps, on the other hand, is a set of best practices specifically designed for ML project, and it can be relatively straightforward to deploy and integrate traditional software. So ML model present unique challenges. They involve data collection, data training, validation, deployment, and continuous monitoring and training. So all these activities seem to DevOps. We are doing data collection, data training, validation, deployment, and monitoring. So MLOps focus on automating the ML life cycle. So automation in ML life cycle is the basic focus of MLOps. it helps ensure that models are not just developed, but also deployed. Now, developing is only ML application. So, developing and deployed, monitored and retains, we can say systematically and repeatedly. So, what is the basic purpose of ML op? Not only to develop model, but deploy, monitor and retain that model until next version is created. So, it brings DevOps principle to ML. Whatever the DevOps principle, like develop, deploy, monitor, it incorporate these DevOps principle into ML by doing developing, deploying, and monitoring all the processes. So MLOps result in faster deployment of ML model, better accuracy over the time, and stronger assurance that they provide real business value. So once you implement MLOps, you ensure that all your data integration, modeling, performance, everything gets boosted because it is an automated process. It will extract the feature, improve the data set, train the model, improves the value, again apply. So, and you just have to observe, monitor and observe, and once you deploy, you have to just update. That's it. So similar to DevOps principle, develop, deploy, and monitor. Here also we try to apply in machine learning operation when you want to deploy. So what is the benefits of MLOps? MLOps helps make machine learning projects smoother and more reliable in many ways. So what are the ways? First is faster model training and deployment. Automatic tasks speed up model training and put it into use. So faster model training and deployment. This is one advantage. Easier experimentation. It becomes simple to try out different model and data to find what works best. So it is up to you. So easier experimentation you can perform, and whatever is working best, you deploy that. Less human error because it is an automated process. It reduces the mistake and can happen when tasks are done by hand. So whatever the human errors that are automatically eliminated using this. Then repeatable and trackable steps. Every part of process can be repeated and checked, making it easier to understand and fix the problem. So repeatable and trackable steps. So you have to fix the problem, and again checking and making new process are easy. So it is comparatively easy and better teamwork. Clear processes and shared tools help teams work together more smoothly. So all smooth operation. You don't only have to create, deploy, and monitor. That's it. So all these are the benefits. Faster model training, easier experimentation, less human error, repeatable and trackable steps, and better teamwork. That limitations also. Complex setup. Some limitations are definitely there, as it is not smoothly as you think. So it has the cost. Complex setup. Setting up MLOps can be difficult and take lots of time for the beginners because you need to deploy it in automated way. So complex setup is definitely there. Without technical experience, you cannot do that. Then higher cost. The tools and infrastructure needed for MLOps can be expensive, making it harder for smaller projects. So for a very small project you develop and you want to deploy it for MLOps, it requires costing. Then limited flexibility. Some MLOps systems are not very flexible, which can make it challenging to try new ideas or quickly change the method. So flexibility, sometimes it is limited. Data privacy and secrecy. Handling sensitive data in MLOps framework requires extra care to protect privacy and information safety because it is an automated process. Your data which is very required to be confidential, sometimes you bring it in the process. So data privacy and security is under stake. And integration challenges. Connecting MLOps with existing tools and processes can be complicated and may slow down the stages of deployment. Sometimes integration and deployment challenges you may face. So you have to be expertise, you have to bear some cost, some flexibility issues are there. Privacy, security may get on the stake, and some integration challenges you also face. So you have to consider whether what are the advantages, what are the limitations. Now, lastly, before concluding, we'll have small case study on MLOps in healthcare. How we use this MLOps in healthcare, that I will try to explain before we conclude. So MLOps is a framework that combines machine learning, DevOps, and data engineering. So this is a combination, as we learn, to manage the entire ML life cycle. So from data collection, deployment, monitoring, and retaining. So this life cycle is completely managed by machine learning operations. So in healthcare system, ML model are widely used in disease prediction, because simple we consider ML model. So you predict the disease by train the model that X, Y, Z are the symptoms, then this is the disease. Then X, Y, Z, if it is not only this there, not there, decision tree classifier, we apply so many classification model and we predict the disease. Then patient risk assessment, early diagnosis of the disease, resource planning. So all these are the ML models which is widely used in healthcare. So MLOps do what to enhance this? MLOps ensure that these models remain accurate, reliable, secure, and compliant. So additional boosting it will add by MLOps, so that existing ML model becomes more accurate. You can more rely. Some new disease came tomorrow and you are not able to identify that disease. But if you configure it with MLOps, then you may rely that anything, suppose COVID is there, some new disease come, then MLOps can also train the model based on whatever the new features are there, because its basic principle is deployment, collection, deployment, monitoring, and retaining. So it is continuous process it is doing. So these advantages we are getting, boosting the existing ML apps, accurate, reliable, secure, and compliant with medical regulation. Now this is the problem that we are having: a multi-specialty hospital implemented with ML model, predict patient risk for chronic disease such as diabetes and heart diseases. So patient required early medical intervention for that. So initially model performed well during testing, deployment. So patient data pattern change, new diagnostic tests were introduced. You are not able to understand new diagnostic tests, how they apply. Model accuracy get reduced. Then manual retaining cost delayed. Regulatory compliance become difficult. So we need for ML, this highlighted the MLOps practices. So we cannot do patient data pattern if it is changed, certain behavior of patient change, then our static ML model will not incorporate this. Some diagnostic, some you allow patients to do some diagnostic test, and some test result are not under your control, means you are not recognizing your ML model. What is that? So accuracy get reduced. So challenges without ML app, normal ML application without MLOps, model drift, disease pattern and demographic changes you cannot identify using normal ML. Data drift, new lab test and medical parameter if they introduce for identifying disease, you cannot include. You have to again redevelop the new model. Then manual deployment, risky and slow updates manually, no monitoring, late detection of accuracy and compliance, lack of traceability and auditability. You cannot audit and you cannot trace whether all the changes are happen or not. This is a very critical application, medical. So MLOps, hospital adopt MLOps to automate, monitor and govern ML model used for patient risk reduction. So key components in MLOps. Now existing machine learning model is getting advanced by applying the MLOps. So data integration and versioning you can apply. So this is first step. You integrate and version the data, automated data pre-processing, model training and validation, and CI/CD based deployment. That is continuous integration, continuous delivery or deployment. This is one of the application of DevOps. Same we are using in MLOps. Continuous integration, continuous delivery or deployment, and continuous monitoring and retaining. So these components of MLOps we apply on ML model, key components. So how we apply? Data collection and versioning. Data collect from electronic health records, lab records, medical image summaries, and wearable devices. So all these data collection and version control for traceability. We analyze the data by this. Then automated data pre-processing. Handle missing clinical values, normalize lab test results, enable categorical variables like gender or symptoms, then remove noisy or inconsistent records, and ensure standardized and high quality data by automating the data pre-processing. Then model training and experiment tracking, this third one. So model training, logistic regression, random forest, neural network, any suitable algorithm we use, and experiment track using accuracy, precision, and recall. So automated tools like MLflow, TensorFlow, which are the advanced tool which you are doing for model training, which we can use. Then next is model validation and testing. Clinical accuracy, threshold applied, bias and fairness check across the age, gender, we can check that whether it is happening or not. Then model failing medical safety criteria are rejected automatically and ensure patient safety and ethical compliance. So whatever is not relevant, that tests are removed and patient safety is integrated by clinical accuracy and threshold value. Then CI/CD model categorized using Docker, deployed secure API, and automated CI/CD pipelines ensure zero downtime, continuous zero downtime. So rapid and safe deployment. Then model monitoring, monitor real-time prediction accuracy, detect data drift and model drift, alter clinical when performance drops. So clinicians are alert, performances drop, and continuous retaining. New patient data added regularly. So it is continuously updated. New patient data, periodic retaining, scheduled, best model automated deployment, continuous learning and improvement, so that it is getting trained and updated. So role of MLOps, reliability, contribute, consistent disease prediction, compliance, auto-ready model tracking, security, secure patient data handling, automation, end-to-end ML life cycle, and scalability. So benefit is improved disease prediction, early identification of high-risk patient, faster clinical decision support, then regulatory compliance and improve patient outcome. So MLOps in healthcare is very, very important because it gives you reliability, compliance, security, automation, and scalability. So how it is improving? Step by model updation. Initially, model agar update karna hai, that you have to do manually. Now it is automated. Monitoring is limited. Certain parameters you cannot monitor, but it is a continuous monitoring. Accuracy also degrading and stable. Compliance is difficult and it is built in based on the model. Scalability is high. So these are the added advantage you get by applying the MLOps. So to conclude, MLOps is critical for developing machine learning safety and effectively in healthcare system. It is very critical. By adopting MLOps, the hospital ensures the accurate predictions, regularity, compliance, automation, and continuous improvement. And it ultimately provides patient care and clinical outcomes. So healthcare gets improved, but some limitations as we discuss about this MLOps. This also costing, complex setup, flexibility, and privacy and security. So after you overcome on this, MLOps become very, very useful for all ML related applications. Okay. So thank you. Thank you very much. Any question? If you have, you can ask.
Yes, participants, any questions?
I hope it is clear or anything from your side.
Any queries? You can type your queries in chat box as well.
I hope I am able to explain in given time whatever the concepts I want to clear. So I want
Yes, sir. It was very nice session.
thank you.
Sir,
Yes.
this I understand. I am not a engineering department, but pharmacy department. We can use in first session this ANOVA, ANOVA, ANOVA. In this yeah, data pre-processing processing.
Okay. Innova. You see, there are
Yes, sir. Yes, sir.
there are many models in pre-processing you can use. Third-party models are also there, but you have to basic what is the purpose of that. That is very important. Nowadays, many third-party tools are also available for data pre-processing. You can use that, but you have to check whether you get required accuracy or not as per your, because data pre-processing is different for different application. It is not same.
Actually, we can use this as a case study of patient. If we give the paracetamol of different patient of different districts, so we can take the find out the average value of patient regarding this process, this data pre-processing.
Yes. See, data pre-processing is not finding the result. You have to make the data ready for processing. That is the pre-processing. So raw data you cannot use as it is. That's why you have to apply pre-processing application. That is the basic purpose of pre-processing.
Okay, sir. Okay, sir. Okay.
I request all the participants to kindly switch on your camera and request sir to please stay connected for a group photograph.
Yes. Thank you all for patiently hearing. I hope you like. I stop sharing my screen now.
Yes, sir, you can stop sharing. So on the behalf of PDS College of Engineering and ATAL-FDP program, I extend my sincere gratitude to you for delivering an insightful and impactful session on ML ops and data pre-processing. Your clear explanation on ML ops practices and the version control model deployment that will definitely help the participants in better understanding. The session effectively bridged the gap between the theoretical concepts and the industry practices which can be used, making it extremely valuable for the faculty members and the researchers. We are truly thankful for your time, effort, and the expertise which you have devoted to this session. Thank you so much, sir.
Thank you. Thank you very much, ma'am. Thank you, sir.
Thank you.
So participants, please stay connected. We are starting soon with our next session, which
Hallelujah,
will
madam.
be
Thank you.
conducted by Mr. Ganesh.
No. Low.
I request all the participants to please stay mute.
Excellent. Hi, can you hear me?
Yes, good evening, Ganesh sir.
Hi, Deepali ma'am. Excellent.
Yes,
Yes, sir.
all
Yes,
the
sir.
participants. Now we move towards the next session,
Yes,
which
ma'am.
will be based on build, save, and deploy a ML pipeline with SK Learning. The session will be conducted by our eminent speaker, Mr. Ganesh. He is a Vice President, Security Architect from Northern Trust, Pune. His specialization areas are data analytics and intelligent automation, cybersecurity, enterprise and cloud security, programming, project management. He is having a 20 plus experience of professional with the IT industry for AI driven programs, data analytics initiatives, and enterprise digital transformation projects. Uh, he has played a key role in aligning AI and analytics initiatives with business objectives, enabling data driven decision making and operational efficiency. Also, his expertise in the security perspective. Let's welcome to you, sir, for this ATAL-FDP. Now I
Excellent.
will hand over the session to you for the next 1.5 hours. Thank you.
Thank you. Thank you. Okay. Right, excellent. So, thank you, Deepali ma'am, and thanks, all those who have joined this session. Okay. So as Deepali ma'am explained, right? So let me share my screen. Pardon with me, like, if I'm sharing it fully, let me do that fully because, we have a couple of windows that need to be shared as such, right? So I hope that is okay. Right. Excellent. Let me know. I'm hoping that you are able to see my screen. Okay. If not, then just ping it, or maybe you can voice over.
Yes, sir, your screen is visible.
Right. Okay then.
Yes, sir. It's very visible.
Excellent. Thank you. Okay. So, as Deepali ma'am already explained, okay, so today we'll be talking more about, building, saving, deploying a machine learning pipeline with scikit-learn, like a sklearn. That's what typically people call it. Okay. So, I know that you have already gone through, various aspects of artificial intelligence, like machine learning. So I will not get into those details, right? And I just came to know that, you also went through the ML ops, framework, right? As a, separate session altogether. But when we talk about the life cycle, right? That's one thing that we'll also have more discussion about, right? We'll also talk about ML pipeline, okay, and then how exactly that can be implemented using a real life implementation that we'll saw. Okay, so I will just demonstrate on how exactly you can use scikit-learn, right, to implement it. Okay, so what we are going to cover in this session, right? So first of all is, we'll be talking more about what machine learning is, what are the features supported by scikit-learn, how can you create pipeline, what are the different, modules that are supported within scikit-learn, right? That we'll also talk about. Key takeaways that we would expect you to have is, right, you understand what the end-to-end machine learning workflows are. Okay, we'll also talk about the best practices which are aligned with it, right, in terms of machine learning as well as the scikit-learn too. So we'll take a quick look at the best practices. We'll also take a quick look at the NIST framework, which is supporting the AI risk management framework too. So that also, like, I will just give you a brief of it, right? I know we have a very limited time, by the way, right? 1.5 hour. It's not something that we would be, covering all the aspects in detail, in depth, the way that we used to. But then at least you will get an idea of like what the ML pipeline is, and a point of view on how to implement it, right? That's a very high level. Okay, so we'll take some sample to train, evaluate, and tune as such. And then we'll also talk about deploying the pipelines too. Few things that you need as part of this session, right? I know I will and also give a walkthrough of it. So a couple of tools and technologies that I already listed out, right? Python, scikit. We'll also take a exhaust. We have an exhaustive list of tools and technologies that are supported. So I will give you a quick brief of that as well, right? Something that is useful for you to take it forward from there. Excellent. Right. So, who am I? Right. As ma'am already mentioned, I'm Ganesh Kungarde. People call me Gigi. Okay. This is my LinkedIn, profile. You can connect me on G Ganesh Connect on LinkedIn. That's where you can always find me. I'm always active on LinkedIn. I'm part of Northern Trust now. I'm in this industry for last 20 plus years, and then currently holding a position of vice president in a security architect, mainly focusing on wealth management and asset management. Okay, so that's being the enterprise architect, right? And I also trained more than 2,000 architects as such, right, in last 5 years. So yeah, this is one area that I love the most, right? Which is engaging and talking to the best of minds, right? Sharing idea. That's how we always learn with it. Okay, so without further ado, okay, let's see what the machine learning lifecycle would be, right? This is an AWS point of view, by the way. Okay, so it's something. Uh, it's not that exhaustive. We'll not spend much of the time here, but at least we should understand what the machine learning lifecycle is, right, at the high level. So if you see, like, typically you have a data preparation, compartment. You have a train and tuning compartment. Then you have a deployment and monitoring, and then you have an interaction in terms of end users, in terms of API integration as such and all that. Okay. So if you look at the data preparation, right, we are really talking about, the raw data which comes in the machine learning life cycle. Okay. Then what are the cleansing mechanism that you apply on the data, right? What are the feature, the labeling part, the tagging part that you are applying on the data itself? Okay. So there are different, features which are supported within the learning itself. You might have heard about transformation, encoding, right, to name a few. So that is a part of the data preparation. Okay, how exactly you are converting the raw data into a way that it is more understandable in the your life cycle itself. Okay, then you prepare, train and tune. We'll talk more in detail, by the way, right? When we are talking about the scikit-learn implementation, we'll also take a quick look at what exactly these models and how exactly they would be supporting each other. Okay, at a very very brief level, by the way. So then we are also will then the machine learning lifecycle also talks about the training and tuning. So it's not only about preparing the data, but once you prepare the data, then how exactly you are training the data, how you are applying the hyper tuning functionalities as such, right, on the data itself. And then once it is ready, then you deploy and keep monitoring as a continuous process. Okay, so this is a machine learning lifecycle view. And I'm sure you might have already got one way or other of machine learning stages, right, I would call it, at a different forums or different working sessions that you have. Okay, though we'll not be focusing more in detail as such on each and every component or the configuration or the parameters, but we'll be referring it, okay, in our session today. Excellent, right? So when we talk about the entire life cycle, so the one interesting thing or the concern to the topic that we are going to discuss today, which is machine learning pipeline. Okay, so what machine learning pipeline entails, right? It's really talking about the sequence of step, right? You are to train your model. Okay, so first, as I mentioned, right, when we are talking about the pipeline, it has an ingress point and egress point. Ingress point is something where you input certain elements into your pipeline itself, and outgress is something that you are taking it as an output or the the result of the given pipeline process as such. Okay, so there are few steps that are involved in the pipeline. So when you talk about left to right transaction, so getting the raw data, loading it, processing the data, applying certain engineering, like in terms of transformation, in terms of encoding as such, right? That's part of the feature engineering. Then you train the model, right? Then you evaluate based on certain parameters, right? And then you deploy the model, right, in the production. Okay, so that's how exactly the pipeline that we talk about. So you can think about, right, utilizing the DevSecOps or DevOps terminologies for machine learning, and that's where you will end up into working with ML ops, right, which is your um operational focus for the machine learning. So for machine learning pipeline, right, what exactly the typical architecture that we can talk about? One being input the data. Now data can be in any format, right? So you have a CSV, text, or any user input that typically comes in. Now those are the voice data, images, videos, right, whatever you can think about that in input data, right? Then there are different libraries that you can use. Scikit-learn, it's sklearn, right? That offers a range of libraries that you can utilize for building the pipeline, having a different pre-processing and model evaluation techniques as such. Okay, so there are different models that are supported by Scikit. Okay, so we'll put like ML pipeline architecture in three stages. One is you are inputting the data, right? What are the different activities that we perform on the input data itself? Then it goes to the scikit-learn, which offers your range of libraries which can be used, right, to perform certain actions like pre-processing, as such, and all that. Okay, transformation is one of it, encoding is another of it, right? And then prediction or the output, that is what exactly we are looking for. Okay, why exactly? What is this particular problem statement that we are focusing on? What is the output that we are looking at, right? Suppose we have two real-time use cases as a sample, right, that I will just touch base upon. But then when you are trying to understand what is the spam or what is the spam message or spam email, right, that is an ultimate output that you can think about. But in order to do that, right, you need to understand what are my spam or decision making related to spam, or any messages that you are having related to your email, or even messages too. So that is your prediction output that we are talking about. Okay, so think about it as a pipeline with an input right on one left hand side, and getting an output or a result on the right hand side. Okay, and in between you apply certain pre-processing and processing techniques as such. Okay, so this is what exactly the pipeline that we are talking about, right? So all these are dynamic in nature, right? How exactly this ML environment will look into, right? So data, as a data pipeline, you can have a separate pipeline for the data itself, because you are getting the data from various sources as such, right? And the data coming over wired network, wireless network, data coming from other systems, right, where you have an API integration, data being generated as such, because nowadays data is an oil, right? It is a new oil. Okay, you have a huge amount of data that is been generated every second. So you need to create that pipeline, right, that is relevant for your problem statement. So this is as per the Gartner, what Gartner talks about the ML pipeline, right? How the ML environment is been segmented, right? So you have a data pipeline, you have a pipeline for dev, right, where you are applying the building of model, training the model, right? And then you have a pre-prod to prod transactions, right, where the data which is being trained, right, move to the pre-prod, which is the testing and validation purpose, and then it moves to the production for deployment and continuous monitoring. So this is a typical machine learning pipeline, right, that is used across, right? We are not really talking about any specific model, right? It may be a bird, it may be a llama, whatever the model that you can think about. So this is the typical machine learning pipeline that you can refer. So as I mentioned, right, different activities that you perform on the machine learning pipeline, right? These are the operational activities. So there is something called as a ML ops framework, okay, which is basically used to monitor that, which is basically used to execute it. So three stages in this framework is the planning, execution, and monitoring. So Gartner, in this is the April 2025 data, by the way, right? So if you look at this data, right, it really talks about who are the market leaders, who are the challengers, right, who are the niche players as such, and visionaries, right? So as you can see the Gartner quotient, right, you still have the AWS, Data Robot or IBM, right, to name a few, which are still the market leaders in the ML ops space. We are really talking about the ML operation. So you have a machine learning pipeline, and then which is encapsulated with ML ops, right, which is think about the same line as DevOps, right, or DevSecOps. But the machine learning ops, the reason why we need to have a separate one, because the amount of data being generated, the amount of model, the amount of intelligence that is being provided, right, or the training that is required. Okay, so you need to have a separate framework to monitor the machine learning related components, right? So that's why we have MLOps. I will not get in more in detail, but I really wanted you to know, to understand it, right, that there is something called as ML ops, okay, which is actually a driving force for your machine learning activities. Okay, so what are the key benefits, right, of the okay, I hope this is visible, right? Can you see the 1 minute, how to hide this? Good, excellent. Okay, so what are the key benefits of machine learning, using machine learning pipelines, right? As we spoke about. So the machine learning pipeline, right, it talks about your data ingestion to ingress and the outgress point. So what it offers, right? The automation, the kind of efficiency it brings to the table, right? The given that it is all machine learning, with a huge amount of data is being generated, processed, right? So having a human interaction with the data will be catastrophic, right? So what we talk about is reduction of human error, right, due to these machine learning pipelines. Okay, uh, because you have certain models which are already been created, listed out, right? Those are basically used to certify the tasks that are being automation put into automation. It offers other features, including the faster deployment, right, modularity as such, even security too, right? We'll talk briefly, because given the background that I'm coming from, right, so I will definitely would love to touch to the security space within the machine learning too. Okay, so given the scalability and the kind of modular performance that it brings to the table, right? So those are the key benefits that we can have for machine learning, right? So what is the practices, like what is the best basic practices, right, that we have for machine learning? So it's a really three-stage approach. Okay, you have a model that model fitting that you typically apply it, right, where you get the raw data, you try to put the data into a certain context, segmentize it, right, then start predicting the data and then cross-validate. Just for example, right, so you have, let's say, list of animals out there. Okay, now model fitting is, right, okay, fine, out of all the things, out of all the living beings or whatever it is, right, you start fitting into the model which is animal. Okay, let's say, then you start predicting, like, out of those animals, right, how many are like dogs or how many are cats, for example. That's what the prediction will be applied, right? And then once it is done, then you cross validate it. It's really a dog. Is there any other way that the dog parameters can be defined? Okay, so machine, it's always about a continuous process. You are learning. So there are two ways that we talk about: supervised and unsupervised learning, right? So what is it that data that we are feeding to it, okay, as part of machine learning practices, and how exactly it will convert into a pipeline. See, our area of focus is having a pipeline, right, that would help us, right, to train those particular models. So that's where exactly the focus area would be. So model fitting, predicting, and cross validation, these are the key parameters for the machine learning practices, right? So what we will be doing is, based on, now we understood what the machine learning pipeline is, what the machine learning practices are, what the machine learning stages, the milestone that we can talk about, right? So we'll be utilizing scikit. They also call it a sklearn. Okay, it says one of the open source library. You have a huge amount of support system that is available, a lot of documentation that is available for scikit. Okay, um, though there are certain limitations, like for example, you cannot use scikit for deep learning as such and all that. Okay, so there is a limit. There are other libraries which supports the deep learning point of view. But then scikit has a different focus area. Okay, any even complex problem also it can solve it, right, to an extent. Okay, but then if you're really into a deep learning, then I would suggest go to the other tools, the other libraries that are available, but not scikit, right? But then in scikit you have a huge support documentation available, right, a very active community, right, which keep updating, upgrading the scikit libraries as such and all that. Okay, so there is a good support system, a lot of tools that are available. Okay, even for fitting, model fitting, or any processing evaluation that you can talk about. Okay, so that's where the scikit comes with. Typically, representation, evaluation, optimization are the key parameters based on which you can refer the scikit. I have given a link here. If you are interested in to know more about, like, the latest one is 1.8, right? 1.8 version is what exactly we are currently using. So you can take a look at the scikit-learn.org, and what is new in version 1.8. There is a huge amount of libraries. We'll just have a brief look at it towards the end of it when we start looking into the a practical implementation of it, right? So I will just give you a brief look at what the latest libraries which are supported by the scikit. But then we will be utilizing scikit, right, to implement the ML pipeline that we have. So how it works, right? What is the end-to-end scikit-learn pipeline flow is. For a namesake, we'll use sklearn pipeline flow. So remember the machine learning pipeline, right? You have a really three stages. One is input data, process it, and then execute, which is output, right? That's how the machine learning pipeline at high level is. But then scikit brings the sklearn brings pipeline brings more flavors to it, right? It gives a more additional milestones or the stages where you can apply certain models or certain processes that can be applied, right? The data that can be enriched, right, based on certain models that you can be supporting. So raw data, then you typically get on train and split, right? Then you have a pre-processing, which you can have a multiple libraries that you can use: imputer, scalar, encoder, to name a few. Different transformer that you can look at, the classifier that you can look at, right? The feature engineering, right? Then it moves to the model pipeline and prediction and evaluation. That's the the sklearn pipeline really talks about. Okay, see, uh, the encapsulation of machine learning was, right, been converted into these 5 different stages that we have. Okay, including to an extent prediction and evaluation as well, because we are not really talking about the output, right? We are talking about the predictions as such, right? What is the level of accuracy that it can bring to the table, right? That's where exactly we are talking about. Okay, 100% is the aim, 100% accuracy is the aim, but then you would really get into 97 to 99% of accuracy for any model that you are talking about, right? So this is how exactly the end-to-end sklearn pipeline flow would be utilized. So when you are working on any problem statement as such, right, this is one thing that you should always look at. We'll talk about one example, as I mentioned, right, about the SMS or the message checker, whether it is a spam or not spam, right? So the raw data in that is a very important one, right? The amount of data that you would provide, right, for the pipeline, for the libraries to learn from it, to see how to gauge whether it is a spam or not, right? That really makes the model more efficient as well. Okay, so why use sklearn pipeline? Why not any other pipeline, right? Because see, sklearn offers certain libraries, right, as I already mentioned. Okay, apart from having a more documentation or the support system where the community support is available, sklearn also offers certain very clear advantages, I must say. Like, for example, it prevents a data leakage. We'll talk about what does that mean, right? How exactly to protect the data within your environment or segment, right? I will show you how to do that as well. Okay, but then understand this, right? sklearn, it combines or it restricts your environment in a way that the data spilling is not really a question there. Okay, so that's how the tight the fitting model that we apply, that's how the encoding model that we apply, right? So it try to prevent the data leakage, right? When I say try to, the reason behind that is you cannot be really 100% sure that it is exactly doing, unless somebody comes it and exploits the way that the sklearn libraries are. Okay, so you are secure until you are exploited. That's how things are. Okay, unless there is a vulnerability, unless there is an exploitation on the any security loophole that you can really talk about. So to an extent, it prevents a data leakage. Okay, it's a very clean, very reusable code that you can apply from the sklearn. Okay, I will show you like how exactly you can do that. It's a very clean, it's very straightforward, the code that you can use it, right, to execute the intention, execute any model that you are talking about. Very easy tuning methods, right? And it also supports a wide range of tuning mechanism like grid search, SWV, and all that, right? So you can also take a look at it, right? Very easy to tune in this particular context too. Uh, Consistent pre-processing, so there is already a model that different libraries that are used to support it. So it's a very heavy pre-processing model that you can refer to. Okay, step by step different training and deployment models that are being supported as well. Okay, and then over the accuracy as well as the prediction that it can offer. So few benefits that you can think about, right? Why the sklearn pipeline would help you, where exactly it would help you. But then you have certain common pitfalls and recommendations as well. Okay, for example, the pitfalls, right? So not everything is great, like as I mentioned, like data leakage, you are having more control until there is someone who is exploiting it. So also we can always think about what might be the pitfalls that you can think about, right? So inconsistent processing, right? Data leakage, controlling randomness. Okay, this is one thing that I really like it, right? Okay, which really the randomness really talks about the drifting of data, right? So how exactly you can control that? How exactly you can control the randomness as such, right? So sklearn does offer certain validation, the cross validation. Remember, in the machine learning at the start of it, we talked about 3 different stages. One is the model fitting, then predicting, and cross validation. right? So sklearn does offer the cross validation, techniques, right? It does offer the estimators, right? It uses a fit and split kind of model, right? Basically, used to control the drift, the data drift, that typically is the major issue within the machine learning, environment, I can tell you. Okay. You can take a look at the other pitfalls. You can there is a reference link that is provided here. Okay. Have a look at it. It's very nice way that it has been represented by the scikit community. So take a look at it. It's more on a positive side of the reading itself. Okay. But then keep in mind, right, the general rule is, right, never call the fit on the test data itself. Okay. So that is a general rule that you should restrict the fitting, the model predicting, because that is basically used for your training, and deployment purpose. So you have a different test and train environment, right? How exactly you can execute that data too. Okay, so always keep that in mind. The best practices, right? So we spoke about certain the pitfalls, like the recommendations. So what are the best practices, right, that are being supported in this particular forum, right? The sklearn does offer, right, as I mentioned, over the control randomness, right? It offers fit and split kind of model, right, to control randomness, control the data drift as such, right? It also, the best practice, like from a security point of view, you should evaluate the model thoroughly even before deploying it for production purpose. Okay, get the accuracy levels checked, right? Make sure that you're using the pipeline. So these are all the security best practices that one must follow when you are implementing the sklearn terminologies or libraries on the given problem statement. Okay, and then you have a continuous monitoring and log security events, which really talks about integrating with your current ecosystem, with your organization security monitoring environment, right? Make sure that you have appropriate use cases created to monitor it, right? Because machine learning has a different level of or different type of engagement too, right? So you need to follow the ML ops model, the ML operations framework, right? And also need to have your monitoring system, security monitoring system, supporting the machine learning capabilities, right? So nowadays, if I am not wrong, like most of the SOC or SOAR environment, they are capable enough, right, to even look at it. Even they have started producing the ML component within their current system. But then it is best way to check with them, right? Whenever you are talking about the security monitoring. Okay, log events, log security events, think about it, like what is my logging framework that I'm using, right? What type of logs that would be generated? Okay, see, we are really talking about the security best practices. Okay, um, and since we are on the security best practices, let me show you quickly the RMF. Okay, there we go. I think I have one open. Okay, so there are different so this is something. Okay, I hope you can see my screen, right? So this is the NIST AI framework, which is a risk management framework. Okay, there's a one very good guide that you can refer to. Okay, it also offers. There is no specific guideline for machine learning per se, but then we have a very exhaustive guideline for security practices for AI itself. Okay, so what are my challenges that you are having, right? How exactly you should have a risk treatment or risk management system put together. Then what are my core RMF core, like govern, map, measure, and manage, right? These are the different support system that I have, right? In terms of govern, like there are certain guidelines that are being provided within the govern itself. So it's quite an exhaustive. Okay, so what I would suggest is you take a look at it, right? Whenever you have some time, right? This is a very good read, I must say, and I very strongly recommend this. Okay, as far as your security specific guidelines are concerned. Okay, so let me switch back to. I wait. What happened? Yeah, excellent. Right. Okay. I do. Okay. Here we go. Right. So we spoke about different best practices that are supported within the sklearn, right? So take a look at it. There are certain framework that we also touch base upon. Excellent, right? So now we'll talk about the solution overview, like what exactly it entails to. We'll be talking more about combining the pre-processing and the different models. Okay, we'll have object for training, validation, prediction, and deployment. The key benefits with the skill learn is really talked about, right? Production readiness, consistency, maintainability. Okay, so now this is something that we'll talk about an example. Okay, I will show you more in detail as well, like in terms of practical viewpoint of it as well. But then just have a look at it for now, because given that we already took a look at what are the different activities which are supported within the pipeline itself. So this will just give one glimpse of it. Like for example, data loading, right? Remember, the pipeline. 1 minute, let me take you back to the, yeah, here we go. So end-to-end sklearn pipeline, right? So this is typical pipeline that we are talking about, and now this is the reflection in terms of what activities that will be performing in those areas. Like for example, data loading, pre-processing, what are the different feature engineering that will be applied, what type of model selection that would be put together, like linear, logistic, or any random forest as such, right? Then you can utilize to build a pipeline. We'll also talk about what are the different components that you can refer, like for example, sklearn pipeline is one of the component that you can utilize it, right, to build a pipeline. Then loading and deploying the pipeline as such. Okay, there are different features that are supported in terms of scaling, right? You have a standard scaler or min-max scaler. Okay, for encoding on the variables, you have one hot encoder. So there are different parameters, you can call it out, right, which are being supported within this sklearn library. Okay, we'll also talk about the very quickly about the job leave and pickle, which are basically used to save the model that been developed, right? I will show you, like I will tell you like what are the different components which are typically referred, that you can also take a look at. But then training the model, right? How exactly you can train the model in, how can you fit it, right, in a given pipeline. Okay, then the evaluation, I mentioned about the certain matrices. Accuracy is one of it, the precision, so these are the different way that you can evaluate the model. What is my accuracy of the model itself? That's one of the criteria that you can employ to, right? And then you have a tuning, right, where you can tune the entire pipeline, right, to make sure that you are optimizing it. It's really part of the optimization, by the way. But then quite an important one, because see, when you are having a ML pipeline as a, see, amount of processing that is going on, right? How much the parameters which are supported by the model itself. Okay, for example, some model have, like, let's say millions of parameters, right? Llama, which is the latest one, having like more than billion. Now what I heard is 2 trillion parameters which are supported by the Llama 4 model. So there are different models which are being created with a different purpose, right? But then you need to understand what is the amount of investment that I am having in terms of the latency, in terms of the cost associated with it, in terms of the problem statement that we are trying to solve, right? So all those parameter comes in, and you start optimizing it, start fine tuning it, right, to reduce the hassle, to reduce the processing time, to reduce the cost, reduce the reach, reduce the type of data that is being supported as well. So hindsight, a simple deployment flow, right, which is a train the pipeline and then save it. So you load the pipeline, you review the data, and then you return the product model prediction. That's the typical high level flow that we can talk about. Now, as I mentioned, right, I will talk about the prerequisites that are used for real time use cases. So we spoke about it, right? Yeah, sorry, somebody speaking. Sorry, I can't hear you.
So I think no one is
No, is it?
else.
Okay.
No,
It was showing me talking something here
no.
on my screen. I don't know what was it, but okay, great then. So so certain components, as I mentioned, right, when you're talking about the real time use cases, right, we spoke about certain elements that are required, okay, and why they are like. So I have provided you some basic list. This is not an exhaustive one, but this is something must have a very basic one. Those are something that is needed, at least to take a look. So first one is the Conda. So this really offers you the virtual environment, okay. So anything that you are doing, right, in terms of machine learning, make sure that you are having a virtual environment dedicated for it or set up for it, okay. Because see, we spoke about data leakage as one of the issue in the machine learning pipeline. If you remember the typical, the issues that we can think about, right, or the best practices which are being supported. So one of it was the data leakage, right. Now, when you have the virtual environment created, it provides you a segmented, work stream, right? And within that itself, you can create different pipelines, and all that. Okay. So Conda is one of the virtual environment, which is basically used to maintain your machine learning pipeline. Okay. You can have multiple, and I will show you, by the way, you can have multiple packages installed within your environment. You can create your own environment, your own project. And now the Conda can make sure that, all the components, data, and anything that you are referring, right, is restricted within that environment. So other environment is not having a connection to your data within the particular environment, right? So cross environment connection is something that you can manage or control using Conda. Okay. And there are other, benefits, like for example, Conda has a very good channel, right? There are, the the Conda 4 channel, right, is a very good one, right. It manages all your dependencies, whatever the libraries that you are looking for. So it offers a very good suite, okay, to support your environment itself. Okay. So think about it as a pre-packaged solution, right. It offers you a pre-packaged virtual environment for you to just have an hassle free implementation. So you don't need to worry about the data spill or data drift as such, across environment connection. So there are multiple benefits that it offers, right. So make sure that you have Conda been considered when you are implementing any machine learning pipeline. Without virtual environment, we don't recommend you implementing any machine learning modules or machine learning projects as such. Please make sure it can be a Conda, it can be Anaconda. So not the real Anaconda, by the way. Don't go and ask for, I need an Anaconda in any zoo shop and all that, right? So please refrain from that. But then a virtual one is okay too. So you can use Conda, Anaconda, right, to maintain the virtual environment, right? Okay. So there are other tools which are also listed out here. Like for example, one is NumPy. Okay. If you are more into, let's say, mathematical calculations, like where you need an arrays, right, which is basically used to have a more speedier, and more efficient responses to your problem statement. So this is based on your problem statement. What is the problem statement that you are having? Based on that, you can have one of these components, right? Must have is Conda, must have is Python. Okay, sklearn, Jupyter Notebook, these are the must have, okay, by the way. But then there are certain, libraries, components, which I will show you how to do that, right, as well in just after this. But then make sure that you have NumPy, okay, which is basically, used to manage, your mathematical functions, it offers great functionality in terms of speed and memory efficiency. Python, we all know, okay, most of you might have worked on Python itself. But then one thing that you can think about, right? So you can have multiple Python instances or iterations within your environment, but then make sure that you have a Python within Conda itself where it is restricted. Because sometimes what happen is, when you have multiple Python instances on your system, right, then when you're executing it, the path, you need to go back to and check the path variable all the time, the environment variable all the time, right, where it is executing, which particular Python it is executing, because you have to have the binding operations that need to be performed within your Conda environment. Hence, it is advisable that you have Python separately deployed within your Conda environment itself. Okay. So that way, whatever activities that you are doing, you have a single packet solution. Okay. That you can refer to. Okay. So this offers various commands, features, right, throughout the life cycle of your machine learning pipeline, or any life cycle stage that you can talk about. Remember the first slide that we saw about the machine learning life cycle view. Okay, so you can utilize Python on any stage of that machine learning Python, but make sure that it is part of your virtual environment, which is a Conda one. Okay, now this is an ID. Okay, Jupyter Notebook is something. There is a Jupyter Notebook lab that you can use it. Right, it's a very good way of executing ask or task that you can say. It offers you a good IDE. Okay, it's a kind of notebook. Those who have referred any editor as such, right? When you are executing any Java code or any other type of code, right? You use editor. So think of it as an editor. Okay, it offers certain features, I must say. Okay, there is another one. You have a Microsoft Visual Studio Code, which is an alternate to the notebook as well. Okay, it is another powerful IDE, integrated development environment, right? Which is basically it supports developing and managing those ML pipelines. Okay. Um, but then it is mostly Azure hosted, right, and all that, right? So it also have a good support of Microsoft too. So there are a lot of good features that it supports. You have probable with that's what I keep hearing about the agentic AI and how exactly they would be utilizing it, right? How easily you can control it through this ID. So there are a lot of integration features that are supported, API features that are supported. No, Jupyter Notebook is a plain notebook, right? But then it's a very powerful one. You can easily see the step-by-step approach. You can execute each line within the notebook itself, okay, to see how exactly it is providing you the output and all. Okay, so it offers an interactive, environment where you can also execute each line of code by that matter. Okay, so the one for testing and as a scalability. So the other one is a sklearn. So this is something that we spoke at early stage as well. Okay, so we'll also be implementing sklearn, scikit-learn. Okay, what we'll be doing is we'll be creating one environment today. Okay, we'll be showing you how to set up your environment, right, and then execute a one sample code for sklearn. But then sklearn, this is another set of library you can install it, right? It supports a range of libraries for pre-processing, engineering, like for any transformation, any encoding feature that you're applying. Okay, and then it also offers certain features in terms of the accuracy or predictions too. Okay, so that's what the scikit-learn component that we are talking about. There is one that I mentioned. Sorry. Okay, uh, there is another one for the pandas, right, which is basically another library, a set of library you can say. Okay, where it provides a more structured format of the data, like it converts the data and put it into more perspective as such, like going from the raw or data to the formatted data as such, right, with a templatized or a structured, like you can call it as a unstructured to structured transaction. Okay, so it does all those cleaning, exploration, pre-processing. So it also offers a library, set of library in the machine learning pipeline. Okay, and that is another feature of Panda. So basically you use NumPy, Pandas, like as a basic to start with, because they have a range of libraries that you can utilize within your pipeline implementation. Okay, then this is one example that I was trying to provide, like a data set. Okay, this is a Kaggle one. You can refer the Kaggle site. Okay, they have collated the data related to SMS. So remember we spoke about one of the use case, right, which talks about the SMS cleanup, right, or SMS message checker, right? Um, so what type of messages are spam message or what are not spam message, right? So this is a data set which it's a huge database, I must say. Not huge per se, but then it's a good database which can give you enough ammunition to try and test your machine learning pipeline. Okay, so this is one. You can download it from Kaggle. You can use it for your training purpose as such, right? You can use it using a scikit-learn or PySpark. Okay. Right. One thing which I missed before I move forward, right? Okay. So if you have any questions, any queries, right, what you can do is you can put it on chat, right? Or I can give my email ID. You can drop me a note where I can come back to you. I know it's very exhaustive one. We are going through a lot of slides, right? A lot of hearing, I must say. Okay. One way monotonous dialogues. Right. So few tools that you would say, as I mentioned, like there are certain components that you would need to have it, but then how to use it, right? So we'll start with Conda. You can go for an Anaconda site, right? Or get the installer from the Conda site itself. Okay. And then you can install it, right? Once you have the mini forge that is installed, okay, you can create environment in it. So we'll tell you like how to create the environment, what is the environment, right? So these are the commands which are basically used to verify it, right? What is the Conda environment, what are the uh, what are existing lists that I have, right, in terms of environment. Then what is my Conda version, that you can check it, right? These are something verification codes that you can utilize. You can activate any project, any environment, right? For example, I have created my sklearn 1 as one of the environment, right? So you can activate that. You can have multiple environments within Conda itself. Remember, as I told you, right, you can have multiple environments, right? But then you need to activate that environment when you start working on it, right? So you can create multiple environments. They can run in parallel as well. You can also create the command center for your all your environments too. So you can have one environment and Conda controlling all your environments as well. So there are multiple layered approach that you can apply within Conda, hence the benefit, right? So you have a different machine learning problem statement, machine learning projects that are going in parallel, being controlled by the umbrella command center. Okay. So this is the mini version, mini 4 that we spoke about, right? It's a community maintained again. It is a pre-configured Conda 4 channel, offers multiple functionalities and features as such. Okay. Now, once you have Conda installed, then you go for Python and the NumPy. You can install Python, right? You can call from Conda itself. Okay, this is the latest version of Python that you can install. The one thing which you remember, like we spoke about, you might have multiple Python installed on your environment, right, on your Conda environment. So how to know where which are the first of all, check, do have Python multi, like you can check using where Python. Okay, see whether there are any multiple implementation of Python itself. Remember, like when I said why you need to do that, because you might have multiple versions of Python, then and you need to set the environment path variable. That is one of the issue why most of the programmers face, right? Then you can check the version of the Python, right, whether it's the latest one or the old one, right, within Python. Now, to disable the number of Python, you can go to manage app execution aliases. You can run it on the Windows, and then disable those which are not required or something that you are not active for that matter. So this is also something you can execute. Then you have NumPy, okay, where you can install using Conda install. Then this is channel, right? The Conda 4 channel. It's a pre-configured channel, okay. It has range of libraries supported within this Conda. So you can take it from it, or you can use a pip install, which is a Python, way of doing it. Okay, you have installer packages, right, which is supporting the NumPy too. Okay, and now if you can check the version using, sorry, okay, you yeah, okay. Please go on mute if you're not talking, or if you don't have any question. Okay, then the import NumPy, or you can also check what is a current version for NumPy on Python too. Okay, there are certain things that I have provided as an additional command that are very helpful, by the way. One is, right, if you see the,
फ्रेंड आफ्टर एज है ये देखो इसकी डियरेस्ट फ्रेंड ये भी है
sorry. Okay, please be on mute, guys. Thank you. Right. So when you have the older version, you don't know like which is the one, the latest one that you are having, for example. So you can go back and then check the upgrade, right? You can have pip install numpy upgrade. This will give you the latest one if you don't know which is the latest one, right? For example, if you really don't want the current version of it, then you can have an uninstall it, right, and then purge the cache, right? So that way it will remove anything, any traces of your previous installation too. Okay, so these are very important and very basic command that you must have. That's the reason we put it on the screen for you to take a look at. Then scikit is something that the one that we just spoke about, right? So then again you go back to the channel, which is a conda 4 channel, right? Then you implement the scikit-learn. Okay, make sure that you are referring the conda 4 channel itself. You can use pip install as well, hyphen capital U with scikit-learn, right? um, so this is one way. You can check whether the what scikit-learn that you have, like the conda list and scikit-learn. So it gives you the build version. It gives you the what is the latest version of the scikit-learn itself, right? Then the build version as well. Okay. If you want to uninstall it or install the upgrade one, you can use the pip install upgrade one. Okay. So this will again install it from the Cofort channel too. Right. Okay. So the last two, like which is talks about the Jupyter notebook. This is something that we spoke about, right? Um, so once you install it, then you can launch it through Jupyter Lab or Jupyter Notebook itself, right? Then the job lib, which we spoke about, right? Once all your action activities are completed, the pipeline execution is done. Then sometimes you want to use that prediction or that model in some other libraries or other program, right? So you can do that using pickle or joblib module, which are basically used as such. You don't need to install pickle separately because it comes with Python 3 as default. Okay, so you don't need to have it installed separately on conda. But then if it's joblib, then yes, you need to have it installed on the conda itself. You can check the version using conda list job lib. That will give you the latest version and the build version that is installed on the environment. Okay, so those are the commands. What we will do is, right, this is the one execution that we'll go through. Okay, but before this, I will show you all these executions that we can have on the environment. Okay, so 1 minute. Right. Okay, I will open both the. Okay, there we go. Right. Okay, so I hope you can you see my screen, or do I need to enlarge this?
Yes, it's visible.
Visible, right? Okay, great.
Yes.
Right. Okay. So let's say first of all, let's check like what is my Conda environment list we spoke about, right? What is my Conda environment list that we have? Okay. So right. Okay, here we go, right? So you see like there are three different verbs that we have. One is C drive Conda, then Miniforce 3, and then in Miniforce 3 you have environment, which is SQL. You see the asterisk one, okay? So the asterisk one is talks about the one which is activate. Like let me say, like if I deactivate this one, let's say Conda deactivate. Okay. So when I deactivate this, then it should activate the base version, which is the mini 4.1. So if I go back again, so see which is the active version of it. See why you need this, because whatever activities that you're doing, that you must have an active environment. So if I'm executing anything, so now if I execute anything, it will go to my base version. See here the asterisk is, okay? So any implementation that will be part of Miniforce 3, that's where the base environment is. But then if I want to change my environment to, let's say, uh, activate, what is it, my sklearn 1. Okay. So this will activate my sklearn 1. So whatever activity that I'm doing, it will be part of MySQL active one. Okay, so there we go. Right. Okay, excellent. Right, so now we have the active environment where we are working it. So first of all, we see what is it that we already have installed. So what we'll do is, like, we'll just see conda list. So it should give me all the list of packages which are installed within this environment, right, which is MySQL one. Okay, I'm hoping it will. Okay, there we go. Right. So there are a lot of packages which are installed, right? Because as I mentioned, right, I already created an environment for you. So there are already some packages which are installed, but I don't know whether I have any NumPy or anything, right? So what I do is conda list, let's say NumPy. Okay, I want to check whether I have a NumPy on it or not. Okay, yes, I do. So I have NumPy with a version 2.4.1. There is also a build that is created, and it is taken from the Conda 4 as a channel. I can also check the other packages like Conda list, let's say pandas. Okay, right, yeah, pandas. Okay, so please make sure that you are typing it correctly, right? Spelling or something very important. Okay, so panda is also something that is already part of it. Okay, in the environment. So version, then build, and then also it is taken from conda. So now let's check the scikit-learn. So do I have conda list scikit-learn? Do I have scikit-learn? Yes, I do. So, which means that whatever is required for me right now, I have all the environments already been created. Okay, so remember we created the Conda environment first. We installed it, then we created environment MySQL one. Okay, if you want, there is a code out here to create the environment. Okay, so you can also use it. Where is conda create? There we go. So you can use conda create env and then put the name of the new environment, right? Then it will create the environment. I'm just referring the first two segment of this code, not the entire one. This code is like, basically to install all the three packages in one single statement. It's like conda create, then it will install Python, NumPy, and Panda. They all three in one single command line. Okay, I will not advise it because then you will be struggling to see where exactly the error or the issue would be. Okay, so there's one thing that you should always think about. But then once you create the environment, right? Once you have the packages installed, okay, make sure that you know which are the packages that you have. Then then what we'll do is we'll start. I will open the another one, this one, right? Okay, now what I will do is remember, like, so we had this numpy, conda, scikit, and panda that is also already there. So let's open the Jupyter notebook. Okay, so it's an IDE which is basically used to to provide the command to provide the readable form of the codes, right, to the environment, right, basically used to offer any execution or any cleaner way of doing it, right, within the notebook. So it's a IDE environment, not powerful IDE, but it offers you a platform enough to start with. So it's a kind of editor that you can utilize it. So let's say I will start Jupyter Lab, right? Do I have it? Okay, okay, right. Right. Okay. So this is an environment that offers, like, if you see here, you have public or HP. So let me see if I can create something in public. Okay. So let's say if I go here, I will create a folder like uh, my sklearn one. Okay, that's a project that we'll have. So within that project, right, I can create, let's say, a notebook. Okay, right. So here you can type like all the code that you have. So first let's rename this. Okay, so this is, let's say, test one. Okay, right. So if you see this environment, right, you have this on the right hand side Python 3 kernel, okay, which is something that we already started. So out here, if you can see on the right, so this is in the backend that it is executed. It is talking to all the libraries, in the backend, and offering you 1 minute, where it is. Yeah. Okay. So see, think about it, right? See what are these extension that it is supporting, right? The kind of the Jupyter server that it is calling to, okay, and then it is offering it as a client. So this will, in the backend, we have an active kernel which is running, okay, which is basically supporting this IDN. It works like a client, and then you have a server running in the background. Okay, so what we will do is we'll switch back to this. We'll take this one example. So remember, like the sklearn execution that we spoke about, the pipeline execution. Let me go back to the slide which we talked about, the pipeline, the sklearn pipeline. See here, okay. So you have a raw data, trainer split, pre-processing, fee changing, model pipeline, and prediction or evaluation. Okay, so just keep that in mind, and just we will have a slight implementation out here. Okay, the reason we put it together already here, because right, we, since we don't have much time, right, so we cannot go directly out there and start testing out it, right? So what we'll do is, we prepare the data, we load the data set using the libraries like pandas. We spoke about it. It offers a cleaner way of representation. Okay, it converts the raw data into a structured format, unstructured to structured, and then split into the features like, let's say, example X and Y. We'll also use the model like train test split to divide the data, and then we'll use this, for the testing purpose. So let me, okay, 1 minute, where it is. So what I will do is I will just copy the code instead of writing it. Here, okay. So what I will do is I will just copy this code. I'll go here, right, okay. So we are importing Panda as a variable in PD. Then you are calling an sklearn module, okay, which is a train and test split module, okay, as a model selection. You can have multiple model selections out here. Okay, you can check what are the models that are supported as said by sklearn on the site that I just mentioned. Let me show you the site as well. Okay, this is the site that we were talking about, right? So this is a version 1.8. Okay, sklearn. There are a lot of features that are supported. You can have a lot of libraries, sklearn base, calibration, cluster, decomposition as well. So there are a lot of support features that are available. Even the API integration as well, right? The matrices, there are different matrices that it supports to. So multiple ways that multiple libraries, very exhaustive one. The documentation is also good, right? It gives a very detailed level. The community, the scikit-learn community is really helpful. You can see these community members who are contributing to this. Okay, so it's very active, by the way, and contributes to this particular environment too. Okay, so if you are interested, be part of the community too, right? Start contributing, and just sharing the wealth, right? Not literally though. So this is one that I will go back, right? So what you have is now, once you select the model, right, you are now loading the data, right? So what we did is, right, we are importing the load underscore iris into the data set. So from sklearn.datasets. Then what we'll do is, once it is loaded into load iris, then we'll have a return X and Y. Okay, so we'll split the data now. Okay, we'll call the X train Y train as such, and so let's test it. So you can test it using the ID as I mentioned. Okay, so you can run this, if it has any error, it will show it as an error. If not, then it will go to the next line. We are not asking for any execution as such out here. It is just allocation and deallocation of certain data points. So in this case, we have an X and Y and a pair, which is loading the data value, right? Then we have X train and Y train combinations. Okay. Then what we'll do is, right, once we have the data preparation, right, then we'll talk about the choosing the model. Okay. So I will just with this, in the interest of time, I'm just doing it, guys. So, but this is not what exactly typically will do. Okay. So what we're doing here is, right, we are importing the random forest classifier, which will work as an ensemble. It is basically a model used for estimator purpose. Okay. Now this is something that will provide us the estimation of weight. Okay. For the model estimation. Remember we spoke about once we have the data loading, pre-processing, then we estimate it, and then we move it forward to the evaluation and all that. So now what we'll do is, right, we'll use this fit. Remember the fit one. Okay, fit and split model, which is basically used to restrict the data within this particular environment. This is something that we will do it in the fit function. Okay, so we'll have fit. There are random classifiers, as you can see. What are the different parameters, like in terms of estimators, criterion, right? So all these data point which are being portrayed as such within the model fit. Okay, remember this is an output till the model dot fit. Okay, so we executed this function. We had this been covered as such, right, in terms of allocatment and segmentation. So once we have the model fit executed, then what we'll do is we'll evaluate the model. Right now we'll try and find the accuracy of it. What is the accuracy of this one, right? So are we having 100% accuracy or anything near to that, right? Let's see. Okay, here we go. So we have model accuracy of 97.37%. That's what the accuracy level that we have found in the current model. Okay, so see, remember the predictions and the accuracy is something also we were targeting to, right? Then you can utilize the tuning purpose. For now, I'm not splitting using the grid search CV, but this is something that you can uh, utilize it, right? What we'll do is, once we have the model train, okay, we will save it as such, right, using the pickle. Okay, as I mentioned, pickle is already inbuilt within the Python itself, so you don't need to install it separately. See, remember why we did not got any error previously? Because we already have Panda installed, we already had a scikit-learn installed, right? Hence it is already taking from that environment itself. So what we'll do is, like, once we import the pickle, now it is saving the model as such to the file, so that you can utilize anywhere later on. Okay, it will give me the the output whether it is saved or not, but then you would know that, okay, yes, my model is something which is been followed, and something that I am saving it for the future purpose. Okay, so this is the typical implementation of the scikit-learn. We created we utilize the data, we apply the pre-processing of it, the different models that were applied. Okay, and then we also tested the accuracy too. Okay, the predictions, and then we saved it for our future purpose. Okay, we'll just give a couple more minutes for it to give us the result, whether it is saving or not. It will take some time to do that. Okay, so let's give. Okay, let me try this again. Okay, let's give one more minute. It should give me the indication whether it is saved or not, or the saving is completed or not. Okay, right. Give one more minute. And pardon me if I'm like rushing bit, because in the interest of time, this is something that I was trying to model it or just manage as per the time frame allocated to me. Okay, right. Okay, so this will take some time, right? It for it to provide the reflection whether it is dumping the model or not, right? It is saving the model. Okay, but then yeah, sure. Okay, meanwhile, till it comes back. Okay, right. So few real world use cases, for spam detection. So one thing which I said, like, you this is the one that you can utilize it, right? This is, maybe you can try it on your own, okay? Where you can get a simple pipeline with an email text like an user one, okay? You can apply certain features in terms of pre-processing or the modeling features as such, right? You can classify it, you can put some vectorization techniques out there, okay, using the scikit-learn pipeline, by the way. And then you can have a prediction, which is an output, right, as a spam or not spam, okay. This is a classic problem, okay. How to do that? So different message checker use cases that you can apply it, right? Data cleaning, then you have data analysis, pre-processing, model building, evaluation, improvement. You can create a website and deploy it as well, so that the external users also can make use of it. So how it typically works? So you can convert the text to numbers. You have a TF to IDF count vectorizer that can be leveraged using scikit-learn. You can train the classifier as well, right? In terms of using anything like logistic regression or any other classifier. Then there is a sample code that I have provided. You can have a pipeline, that you can import using scikit-learn, sklearn pipeline, which you can import, and then the extraction features that can be imported as such, and then the anything that you can go for, either logistic regression or the naive Bayes. Here they are referring a naive Bayes. So this is just one sample code that you can refer to, but then you need an exhaustive one how to further model it, okay, by the way. Then the pipeline is created with the vectorizer, and then the naive Bayes classifier that had been utilized, okay. Then you fit the pipeline, as I remember, as we spoke, right? You need to have the fit and split kind of model, right? So you need to fit it, make it more structured, more segmented, right? So that the issue of data leakage is restricted, okay. Is something that is controlled as such. So all the time you need to utilize it as such, okay. And then the prediction, which is accuracy or any output or that you are trying to provide using this code itself, okay. So for this one, there is something called as the data code that is basically used. I can show you. I already downloaded one from the Kaggle one. So this is one thing that I was trying to show you. Where is the okay, right? So if you go here and say Kaggle, right? Yeah, your machine learning and data science community, right? So they have a data sets out here. You see the data set, okay. There are a lot of options that are being offered here. So you can go here and check the data sets, right? What are the different data sets that you can leverage? So it's something that you can leverage it. See, one thing you should keep in mind, right? The pipeline that you are creating is based on the data that is being supported. So you have to have a good and clean and verifiable data. See, nowadays the issue that we are facing, right, in terms of machine learning implementation is having the credible and authentic data, right, which has been fed to the machine learning processes as such, right. So make sure that you have an authentic source of the data from where it is coming. You have because you need to apply a cleaning level, and all that. So there are different data sets that are being offered here, okay. So the one data that I downloaded is like SMS spam. Okay, so yeah, this one, the SMS spam collection data set, right? So you can go out here, right? You can just download it, and then use it for your uh, this purpose. So I will show you. You can go here, right? Okay. So what you can do is load. So I already have this one, right? See, this one gave me a CSV format, but then something. Okay, here, right? This is given in a CSV format, but then due to the UTF-8 encoding and all the error, I had to convert it into the text format, right? So that way it will load it properly. So this is something that you can use it. So I can go here and let's say I use the spam 2, for example. Okay. Right. So this is what the data is, right, for the spam data. Okay. This is for one example, by the way. We are talking about the spam detection use case, right? And then this is the data that is already been populated. Okay. You can refer the data, create a model, right? You see that this has a huge, data set, a good amount of statement, like 5,575 statement that are already part of it. Okay. So this is the raw data. Now you need to apply this raw data, clean the data, right? Put it into a structured format using pandas, numpy, okay, and then apply the pipeline, or the transformers or encoders as such. Okay, so this is what is important when you are executing it, right? It's still not there. Okay. Then there is another use case that I would like to show it to you, right? This is the spam detection we spoke. So alternate use case do you have is house price prediction. Okay, you can take a look at it, right? So what are the parameters, like, that are required for this prediction? One being, let's say, you have size, location, number of rooms, etc. Like, these are the home features. Okay, and so what area that the house is currently, right? Okay, can I predict based on what? What is the size, area? What is the environment nearby? Okay, what are the facilities which are being offered? Okay, do they have a hospital, school, right? The market, okay, the connectivity to go out. So even what is the size of the now that those are the external factors. What are the internal factors? Internal factors being, the make and model, right? What is the year of construction, right? Is it something been approved? Okay, is it something having good I would say the completion certificate, or does it has the area, like what is the area, like what is the maximum area that is offered, right? Carpet area, built up area, okay, what is the construction quality been supported, right? What are the additional things that are being offered, like in terms of furniture and all that. Okay, see, we are talking about the house price prediction, right? Not for a single location or single house itself, but this particular should be this is an example that you can use it, right, to build a application, right? There are a lot of applications out there, right, which is used for house price prediction based on AI itself. So what type of input that you say, more the input that you are providing, the more your model will be able to gauge it, more it will be able to predict it. Okay, remember, the accuracy will only come once you start training your model itself. Okay, then you apply the regression or any scaling pre-processing techniques or any model that has, right, on it, and then a prediction estimate. Say, remember it, right? For here, like, the numerical features that are basically used to quantify it, right? We are not here doing a qualitative analysis. The previous one, it was more text based, right? It is a more qualitative analysis based on the input that is provided. Here it will be more quantitative one, which is talking about the numerical features supported, right? Then you have a trained regression model, which is basically used to train the model itself. And then you deploy it based on your price estimation. So you can give a comparative analysis. You can offer the machine learning model can offer the certain options as well, in terms of what is a nearby location, as well, right? Good something which matches to the price estimation that they have put together. So there's one way of looking at it, right? Another example for house price prediction, there is also a code that is provided. It uses a certain impute feature. It is an imputer and the standard scaler, because it's all numerical, so you need to have the scaling techniques for pre-processing, and the linear regression model, right, basically used to quantify the price estimation that you have. Okay, so again, if you see that you are applying the fit model, fit and split, because it is something that you want to bind it, right, as far as the model is concerned. Okay, so this is another example that I have for house price prediction in a pipeline. Okay, so we spoke about a couple of things, so I will just wrap it up, right? Um, with with this one. Okay, so what we try to cover out here, okay, The ML pipeline, we spoke about what are the different stages of the ML pipeline and why exactly they are being utilized, right? How exactly they are used. We spoke about modeling, fitting, and predicting as such, right? We have spoke about the cross validation too. Okay, the combined process pre-processing and models, right? Using the pipeline, we saw the pipeline, right? We saw how the scikit pipeline will also help, right, in terms of data loading, in terms of having a pre-processing models, in terms of having some feature engineering models, right, like transformers, encoders, joiners, right? What are the different models that you can utilize it? And then moving forward with fine tuning as such, evaluation models, and then providing the accuracy towards the end of it. We also talked about how to train, evaluate, and tune the models, right? The data without data leakage, right? We utilize the fit and split, right, to even control our randomness, right? Which was typically an issue for the data drift as such, right? As a lateral movement, so you wanted definitely to restrict it to the specific environment. We saw scikit-learn implementation, okay, using the virtual environment, which is used to restrict within the given segment as such, with support of multiple libraries, right? We saw the scikit open source library offering multiple components, multiple features, right? Different models that it can support with a good exhaustive documentation, with a good community support, right? That is something also we saw it, that we had a demonstration on. Then we saw how to save those pipelines, right? We either using pickle or joblib, right? That essentially you can save the pipeline as such. Okay, so I hope that you had a key takeaways out of it by understanding the end-to-end ML workflow. Okay, we had the the best practices which are being referred in terms of the machine learning best practices, as well as the security best practices. We also looked at the NIST AI RMF very briefly. I won't say we looked at it, but we just touched upon. Okay, it in itself is a huge and exhaustive documentation that need to be covered separately. But then I hope this will give you an idea to take a look at it again and again. Make sure that you have it referred, printed, and kept it onto your desk if you are more into the AI space itself. Okay. Right. Separate tools and technologies. We saw multiple tools and technologies which are supporting this particular session, including Python, scikit-learn, Conda for creating the virtual environment, Jupyter Notebook. We also saw NumPy and Pandas as well. Okay. Now, having said that, I hope covered the agenda completely. If there are any questions, you can put it onto the chat or you can send me an email. I will give my email ID right here on the chat. Okay, so that is gng0120@gmail.com. You can drop me a note. You can send me what question you have, right, about any specific area within the machine learning. Even if not, then you can also ask me any security specific questions as well, right? I don't mind. But then put those questions to me on the chat, right, on the email, right? I will try my best of ability to respond back within time. Okay, I hope this provides you enough ammunition to kickstart your journey on the AI space. I know that you are already part of various initiatives in ML and AI, but then this will give you some additional features. Yeah, Deepali ma'am, I think I am done.
I have a
Anything?
question. Can you please, if you'd like to answer it?
Sure, sure. Go ahead.
Yeah, points are there. The first thing is you are talking about that
Yeah,
first to split the data into train and test, right?
right.
After that, you go for the pre-processing, right? So if the data is not processed properly and we are applying the unprocessed or unclear data, which is having the noise definitely for the
Yeah.
test purpose. So do you think the model will give the right answer?
It
All
won't. The accuracy level will be lesser. See,
or-
first of all, we need to, there is no right or wrong for it for now. Okay, because it is all learning and training that based on the data that is being supplied. The first step that we talked about is the data cleaning. Okay, unless we have a clean data, the output or the throughput that it is generating will always be a questionable one. Okay, but the thing is how much accurate it is. That's the only question. Okay, what is the level of acceptance that I have in terms of the percentage? Let's say if I have a data which is clean and applied a pre-processing to it, so am I fine to consider the data which is 50% accurate? Now that is a question, that is a answer, that is something that you need to decide. What is the level of acceptance that I have? Sometimes even 98 99% accuracy is also not enough, because it contributes to your further processing as well. Suppose you are creating a pipeline, right, with certain data that you have applied a processing on with a 50% accuracy, but then that data is contributing to your more sensitive architecture, more sensitive pipeline, then the basis that you are converting the data into, right, will itself fail, right? So we need to understand what is the level of accuracy that I want to target. What is it that I know this particular data that I would be utilizing for? What is my acceptance level? Okay, what is my accuracy level that I will focus on? So does that answer your question, or do you have any follow-up?
No, in fact, the cleaning is required, right?
Right.
Because the pre-processing is not only the cleaning, it's required the scaling also. It
Oh
requires
yeah.
the data normalization, the regulation also. So if the data is not at all in the smooth way, right? So it cannot be fruitful for the testing purpose. Although the unseen data is very much required for the testing purpose. And for the balancing, we are using the k-fold cross-validation. But in my opinion, I am strongly believe that the data should be pre-processed first, then it
Oh
is
yeah.
divided into the train and test.
Absolutely. So if you remember the pipeline model that we were talking about, right, cross validation come later on. You have certain fitting, then pre-processing, right, and then the cross validation for it. So unless and until you have the data been cleaned up, right, pre-processed in a structured way. Remember, like we spoke about pandas very briefly, right, about one of the component that we were talking about. So it really is used to convert from your unstructured to the structured form of it, right? So that's one of the area, that's one of the tool I would say, and that's not the only one. But then you are right. So unless you have a data cleaned up, pre-processed, right, what is the amount of accuracy that it will offer? A lesser one. And then your acceptance level will also go down, then your prediction level will go down, then the output that you are contributing to the other pipeline will also go down. So your entire pipeline, entire life cycle of your that machine learning, the solution that you are bringing to the table, I don't know what problem statement that we are trying to solve, but then it is creating more problem. Yep.
Sir, I want to ask about the
Yeah,
accuracy.
Dinesh.
Yeah, yeah.
That is, there are, sir, we can calculate the accuracy by using the false positive and false negative and the formulas associated with it. So, how much accurate, matlab, what is the basic criteria for its accuracy?
Well, well, that itself is an exhaustive one, I must say. Okay. So as I mentioned that, first of all, there is no right or wrong. Okay. So sometimes depending on the problem statement, one, secondly, what level of information that you are utilizing or consuming, right? That's the second one, right? Then so there are multiple factors, by the way, that what I'm trying to enlighten or give my point of view. And when I say my point of view, which means that it is a point of view, we can have multiple point of views and there is no right or wrong to it. It really goes back to what is your problem statement that you are targeting. Okay. Does it has the minute level of accuracy that is required, like 9 times 0, 9 times 9, right? So what level of accuracy that we are talking about? Or are we okay to play around like 90 to 95 level of accuracy? Okay. So it really depends on your problem statement, really depends on the type of data that you are consuming, right, and how exactly you're utilizing. So if you ask me what level of accuracy, what percentage of accuracy is required, yeah, that is a very subjective answer, or rather question as well. And then it really differs from problem statement to problem statement. In one problem statement, you might, let's say you have a uh, let's take one good example, right? Rocket launchers. Okay. Now the level of accuracy that is required, even if it is changed by point 9 times 1, the position of the satellite, right, will be far away than what exactly we might have position. So there the accuracy level is 9 times 9 as well, right? Even more than that. But then if you are applying that to, let's say, a problem where we are trying to solve 10 plus 10, right, then the level of accuracy that how much is required would be a different then, right? So it depends on what problem statement that we are trying to solve. Second, what kind of data quality that we have, and the output that we are expecting, and how that output will be utilized further. It's not only generating the output, right? As I mentioned, the output of one pipeline is an input for other pipeline as well. So based on the output of one pipeline, is it enabling the other pipeline to work in an efficient manner? That's the question. Yeah.
Okay, sir.
Yeah. Okay. Yeah, if any additional follow-ups, any questions, feel free, right? You can drop me a note. I already shared the contents out here, my email ID. So please provide feedback. Anything that you would like me to improve upon, I would be more than happy to understand that too. Excellent. Thank you, ladies and gentlemen. Thanks for time. Thank you, Deepali ma'am. Over to you.
Thank you so much, sir, for your nice session.
Yeah.
I request you to please stay connected. I request all the participants to please switch on your camera for the group photograph.
Nice one. Okay. I don't know how
Lastly, I
that would
would
work
like
then.
to thank you, sir, Ganesh sir, on the behalf of PDS College of Engineering and ATAL-FDP. I would like to convey our sincere appreciation for conducting and enlightening this session. The way you have structured the discussion around the complete machine learning flow, I hope that it will be really helpful for the participants. The examples and the demonstrations which you have shared during the session made the complex concepts more approachable and application oriented. The session, as well as the feedback which we have received from the participant, that was very grateful. And we are thankful for your time, thoughtful preparation, and the willingness to share your expertise. Thank you so much, sir, for being
Thank
with
you.
us.
Thanks, everyone. Thanks for your time. Cheers. Happy
So, a
learning.
little announcement for the participants. Tomorrow will be the last day of the FTP. So, our session will be starting from 2 p.m. Tomorrow we will be having three sessions. First session will be from 2 to 3:30, which will be conducted by Dr. Rahul Son Kamble. Then the next session will be from 3:30 to 5 p.m., which will be on the HAI, which will be conducted by Mr. Vivek Ramdave. And the last session will be from 5 to 6:30, which will be conducted by Mr. Shivank Sharma. After that, we will be having the quiz from 6:30 to 7:30, which will be conducted on the online ATAL portal. And after that, we will be having the valedictory function for half an hour. Thank you so much, all the participants. Hope to see you tomorrow from 2 p.m. onwards.
Thank you.
Ma'am, we do not have off because it is a 5 to 6 hours session.